Picture a single photon, a tiny messenger of light, travelling in a straight and lonely line across the freezing void for 1,000,000 years before finally striking the lens of a telescope. It carries the faint ghost of an ancient explosion, an echo from a time before the first human ancestor even existed to look up at the night sky. This microscopic traveller is just one whisper from a universe filled with overwhelming invisible power and dynamic, evolving history. Imagine a realm where gravity is so absolute and tyrannical that a single teaspoon of its crushed metallic surface would weigh as much as an entire terrestrial mountain. Here, the sheer density of matter physically warps reality, forcing time itself to slow down and dragging the very fabric of space into a frantic, spinning whirlpool. These are the hidden leviathans of the deep, dark, impossibly heavy engines spinning hundreds of times every second in a silent metronomic rhythm. Surprisingly, these terrifying cosmic forges also offer a steady guiding light in the overwhelming dark, acting as the ultimate compasses of the cosmos. A golden map etched onto a metal plaque currently drifts in the interstellar space beyond our solar system, pointing the way home across the stars using the exact frequencies of these rotating beacons. We are forever tethered to the infinite ocean of space by these precise, ticking clocks scattered throughout the arms of the Milky Way. Deep within the comfort of your room, you are completely shielded from this chaotic violence and the incomprehensible scale of the stellar graveyard. The heavy, comforting weight of your body sinks deeper into the mattress, finding a calm, steady rhythm that mirrors the peaceful unwinding of the terrestrial night. You're safe. These wonders are yours to inherit as you sleep, a grand cosmic legacy waiting just beyond the softening edges of your closed eyes. Allow your mind to drift away from the present, reaching back across billions of years to witness the violent creative forces that shape the cosmos. Out of the catastrophic annihilation of giant stars, an entirely new classification of celestial entity is forged in the silent absolute dark. Out of the catastrophic annihilation of giant stars, an entirely new classification of celestial entity is forged in the silent absolute dark. When a massive stellar body exhausts its nuclear fuel, the resulting supernova casts its outer layers across the cosmic ocean in a blinding display of destruction. What remains is a core so violently compressed by its own gravity that electrons and protons are fused entirely into neutrons. This newborn entity exists as an impossibly dense remnant, hiding in the shadows of the expanding stellar debris. The sheer violence of its birth sets the stage for a solitary existence spanning billions of years. Without the radiant energy of fusion to sustain it, the sphere becomes a cold, dark monument to the Titan that once dominated that region of space. Drifting through the freezing void, this undead star is anything but peaceful. It carries the immense rotational momentum of its massive progenitor, compressed into an unimaginably tiny diameter. The resulting cosmic structure is a tightly wound spring of raw kinetic potential, waiting in the blackness. Conservation of angular momentum dictates that as the dying star collapses inward, its rotational velocity must increase exponentially. A stellar core once taking weeks to complete a single revolution now spins on its axis dozens or even hundreds of times every single second. This dizzying mechanical rotation transforms the dead remnant into one of the most dynamic engines in the known universe. Surging from the magnetic poles of this rapidly rotating sphere are twin beams of intense electromagnetic radiation. These powerful jets of energy pierce the surrounding darkness, sweeping across the cosmos like an erratic, hyperactive lighthouse beam. Anything caught in the path of these sweeping beams is briefly bathed in a torrent of high-energy particles. If we were to look closer, the sheer mechanical violence of this rotation defies human comprehension. The equator of the star whips through space at a significant fraction of the speed of light. Yet, despite this terrifying kinetic energy, the structure holds perfectly together, relentlessly sweeping its twin spotlights across the galactic plane. density takes on a terrifying new meaning when considering the physical composition of these stellar corpses. The gravitational collapse during their birth crushes atomic structures until the empty space normally existing between a nucleus and its electrons is entirely eliminated. Matter is packed so tightly that a single teaspoon of this material scooped from the star's interior would weigh roughly 1 billion tons. To visualize this, one must picture the entire mass of Mount Everest compressed down to the size of a sugar cube. This absurd concentration of mass warps the very fabric of space and time in its immediate vicinity. Escaping the gravitational pull of such a concentrated object would require a velocity roughly half the speed of light. This extreme state of matter, known as neutronium, simply cannot exist anywhere else in the natural universe. If that same teaspoon of material were somehow transported to Earth's surface, it would instantly violently expand, having been released from the crushing gravitational pressure that forged it. Within the star, however, it remains locked in a state of unimaginable compression. From our distant vantage point on Earth, the mechanics of these sweeping beams translate into a mesmerizing rhythm. Because the magnetic poles rarely align perfectly with the star's axis of rotation, the radiation beams trace massive cones through the cosmic dark. When one of these sweeping cones happens to intersect our planet, telescopes register a brilliant, fleeting pulse of energy. This rhythmic flashing against the blackness of space is what originally gave these objects their defining name. Early astronomers detecting these signals were stunned by the absolute mathematical precision of the metronomic beating. The pulses arrived with such perfect, unwavering regularity that they were initially mistaken for the deliberate transmissions of an alien intelligence. We now understand that this steady beating is the signature of a dead star slowly winding down its rotational clock. Every precise flash recorded by our receivers is a single photon burst travelling across thousands of light years just to graze our instruments. It is a haunting, persistent Morse code broadcast without a sender, illuminating the vast emptiness of the galactic night. Invisible architecture dictates the chaotic environment immediately surrounding these hyperdense spheres. As the original star collapsed, its magnetic field lines were squeezed infinitely closer together, amplifying their strength to terrifying levels. The resulting magnetic fields are trillions of times more powerful than the protective magnetosphere that shields our home planet from solar winds. Navigating near one of these entities would instantly prove fatal to any known biological or mechanical system. The magnetic forces are so overwhelming that they physically distort the shape of individual electron orbits, stretching atomic structures into elongated cylinders. In this domain, chemistry as we understand it completely breaks down and ceases to function. These twisted, invisible lines of force govern everything that happens in the star's immediate vicinity. They act as colossal particle accelerators, grabbing stray electrons from the vacuum and whipping them outward at relativistic speeds until they emit blinding light. It is this exact, unrelenting magnetic violence that ultimately generates the sweeping beams of radiation, defining the dead star's existence in the silent dark. A violent birth inevitably leaves a spectacular, lingering mess in the surrounding interstellar medium. Young pulsars are rarely found in empty space. Instead, they sit at the heart of vast glowing clouds of ejected gas known as supernova remnants. These vibrant, expanding nebulae act as massive projection screens, illuminated from within by the furious energy of the spinning core. The energetic winds generated by the central star slam into the slowly expanding outer layers of the original explosion. This continuous collision superheats the gas, causing the entire cloud to glow with an intense ethereal light across multiple wavelengths. Filaments of intricate glowing plasma stretch for light years in every direction, painting the absolute darkness with neon hues. Watching these nebulae evolve provides a real-time display of the pulsar's tremendous invisible power. The structure of the cloud constantly shifts and ripples, reacting to the high-energy particles continuously pumped out by the dead star at its center. Over tens of thousands of years, this glowing shroud will eventually dissipate, leaving the beacon to flash alone in the void. Picture the Crab Nebula, a sprawling tangled web of glowing filaments suspended in the constellation of Taurus. To the naked eye, or even through a standard telescope, it appears as a silent, frozen explosion in the deep night sky. Yet, hiding exactly at the geometric centre of this expanding chaotic beauty lies the true engine of the nebula. A tiny, furiously spinning core mere miles across dictates the behaviour of the entire light-year spanning cloud. This unseen maestro rotates 30 times every single second, churning the surrounding magnetic fields into a frenzy of high-energy plasma. It is a stunning paradox of scale, where an object smaller than a typical terrestrial city commands an astrophysical structure larger than our solar system. Without the relentless energy output from this spinning dot of neutronium, the surrounding nebula would have faded to black long ago. The core acts as a tireless cosmic battery, injecting fresh streams of accelerated electrons into the gas and keeping the spectacular colours burning bright. It is the invisible, beating heart keeping the ghost of the supernova alive. Descending through the intense radiation fields to the actual surface of the star reveals a landscape of impossible stillness. Despite the furious magnetic storms and relativistic winds raging above, the exterior of the remnant is a perfectly smooth, solid crust of iron. This metallic shell is forged under gravitational pressures so extreme that the iron atoms are locked into a flawless, unyielding crystalline lattice. The sheer weight of gravity ensures that this crust is one of the most perfectly spherical objects in the universe. Any deviations or imperfections are instantly crushed flat, meaning the entire star varies from a perfect sphere by only a few fractions of a millimetre. It is a polished, frictionless mirror of hyper-compressed metal, silently spinning in the dark. Attempting to fracture or dent this iron shell would require forces beyond astronomical comprehension. It is a silent, frozen wasteland where nothing moves, nothing breathes, and nothing changes, completely isolated from the violent plasma storms raging just inches above its mirror-like finish. This unyielding barrier hides the even stranger, fluid mysteries that lurk deep within the star's interior. Surprisingly, the universe allows a very select few of these celestial lighthouses to bridge the gap into the visible spectrum. While the vast majority announce their presence strictly through invisible radio waves or lethal X-rays, a handful of these young, hyper-energetic stars actually emit optical light. They produce a faint, ghostly glow that can be captured by humanity's most sensitive optical telescopes. Observing one of these optical beacons is an exercise in extreme patience and technological precision. The light is so incredibly dim that astronomers must use high-speed cameras capable of taking hundreds of pictures per second to catch the rhythmic blinking. When the data is compiled, a tiny, faint point of starlight can be seen pulsing steadily against the overwhelming blackness. This visual evidence provides a hauntingly direct connection to the dead star spinning light years away. Instead of looking at jagged graphs of radio frequencies, we are seeing the actual physical light generated by the magnetic fury of the pulsar. It is a tiny, desperate flicker in the cosmic ocean, a visual heartbeat proving the dead star still holds onto its energy. Plunging beneath the unyielding iron crust, the physical rules of the macroscopic universe completely unravel and cease to apply. In the deepest, darkest depths of the star's core, the overwhelming pressure forces matter into an exotic quantum state known as a frictionless superfluid. Here, the heavily compressed neutrons lose their individual identities, flowing together as a single, continuous, perfectly smooth liquid. This bizarre substance possesses absolutely zero viscosity, meaning it could theoretically flow in a perpetual circle forever without losing any energy to friction. It is an environment of utter silence and perfect fluidity, utterly unlike anything scientists can synthesize in a terrestrial laboratory. The core effectively operates as a macroscopic quantum object, governed by the strange laws of subatomic physics on a city-sized scale. This frictionless ocean sloshes silently beneath the solid exterior, occasionally interacting with the crust in violent, unpredictable ways. It is the ultimate hidden sanctum, a realm of pure, undisturbed physics isolated from the rest of the cosmos by miles of hypercompressed iron. Within this perfectly fluid dark, the true, bizarre nature of the pulsar remains forever locked away from our sight. While the true, bizarre nature of the pulsar remains forever locked away from our visual sight, we have found another profound way to experience their existence. We cannot see through the hyper-compressed iron, nor can we illuminate the crushing dark, but we can listen to the rhythmic echoes they broadcast across the galaxy. Radio astronomers routinely capture the invisible electromagnetic pulses emitted by these sweeping beams and translate them directly into audible sound. This translation process bridges the gap between the unimaginably vast scale of the cosmos and the intimate human experience of hearing. By converting the frequency and timing of the radio waves into acoustic signals, the silent flashing of the dead star becomes a tangible physical vibration. The cold mathematical data collected by massive dish antennas is transformed into an eerie, compelling acoustic performance. Through this auditory lens, the galaxy is revealed not as a silent void, but as a vast, resonant chamber filled with the rhythmic beating of stellar remnants. The isolated flashes of radiation coalesce into a continuous driving tempo, offering a sensory experience of objects that are otherwise incomprehensible. It is a profound shift in perspective, allowing us to close our eyes and literally hear the rotation of a hyperdense sphere located thousands of light years away. The resulting audio tracks generated by these distant beacons are as varied and complex as the stars themselves. Some pulsars, having spent millions of years slowly bleeding away their kinetic energy, produce sounds that resemble slow, deliberate knocks against heavy wood. These older, slower remnants beat out a patient, methodical rhythm, sounding like a tired giant dragging its feet through the dark. In stark contrast, younger or newly energized stars spin with such ferocity that their translated pulses blend together into continuous high-pitched tones. These rapid-fire emissions create sounds reminiscent of an angry insect or the sharp whine of a distant power tool. The sheer speed of the rotation blurs the individual flashes into a single, aggressive hum of pure mechanical aggression. As you lie there, feeling the steady, slow beating of your own heart, consider the vast spectrum of these cosmic rhythms. The universe hums with a chaotic symphony of these overlapping beats, from the agonizingly slow to the terrifyingly fast, each telling the unique story of a star's violent past and relentless present. The diversity of these sounds paints a vivid acoustic portrait of a galaxy teeming with hidden spinning engines. Millisecond pulsars represent the absolute extreme end of this auditory spectrum, spinning hundreds of times every single second. At these incomprehensible velocities, the individual pulses arrive so quickly that human ears cannot possibly distinguish them as separate beats. Instead, the resulting audio translation is a smooth, continuous musical note, often hovering around the pitch of middle C or higher. To generate such a high-frequency hum, the equator of the star must be travelling through space at an astonishing fraction of the speed of light. The kinetic energy required to maintain this continuous musical tone is almost beyond calculation, yet the star holds together perfectly under the strain. It is a flawless, hyper-fast metronome, singing a single unwavering note into the silent void. The acoustic purity of this hum is a direct reflection of the star's incredible mechanical stability. Unlike terrestrial instruments that fall out of tune or mechanical engines that stutter, these hyper-fast remnants maintain their precise pitch for millions of years. They are the most perfect tuning forks in existence, generating a flawless, continuous song forged in the crushing depths of extreme gravity. Picture a celestial choir where each star contributes its own unique rhythm and pitch to the immense chaotic background noise of the universe. If we could somehow hear the entire radio spectrum at once, the galaxy would sound like a massive avant-garde symphony tuning up in the dark. Millions of invisible metronomes, each ticking at a slightly different speed, weave together a complex tapestry of overlapping beats and continuous tones. This cosmic choir is never silent. It is a permanent underlying soundtrack to the slow evolution of the Milky Way. The deep thumping bass lines of the ancient remnants anchor the composition, while the high, sharp whines of the millisecond stars provide a piercing, frantic melody. Every dead star, regardless of its age or speed, adds its voice to this eternal rhythmic performance. Allow the tension in your jaw to soften as you imagine the sheer scale of this invisible symphony playing out above you. It is a comforting realization that the apparent silence of the night sky is merely an illusion, hiding a vibrant, chaotic auditory landscape. We are surrounded by this grand, unseen choir, a rhythmic testament to the countless stars that have lived, died, and continue to spin. The Vela pulsar offers a distinct rhythmic anchor within this cacophony, spinning at a relatively leisurely pace of 11 times per second. When converted to audio, its signal does not blend into a continuous hum, nor does it drag like the slowest remnants. Instead, it sounds exactly like a distant, energetic drum beat, laying down a driving, percussive rhythm against the static of deep space. This specific, bouncing cadence makes it one of the most easily recognizable voices in the cosmic choir. The steady thump, thump, thump of its rotation evokes the feeling of a massive engine idling, a rhythmic pulse of raw power radiating outward. It is a visceral, driving beat that perfectly captures the mechanical reality of a massive sphere whipping through the vacuum. Listening to this steady drum beat, one can almost feel the physical rotation of the iron-crusted sphere. It is a hypnotic, grounded sound, completely distinct from the frantic whining of the faster stars or the mournful knocking of the ancient ones. It stands as a perfect mid-tempo metronome, beating out the time in the constellation of the sails. However, the perfect rhythm of these celestial metronomes is not entirely immune to sudden, violent disruption. Occasionally, microscopic variations in their internal structure or surrounding environment will cause a sudden stutter or skip in their rotation. These microscopic flaws temporarily break the hypnotic spell of the continuous beat, introducing a jarring element of chaos into the otherwise perfect cosmic song. These auditory stutters are the acoustic signature of extreme physics playing out beneath the unyielding iron crust. A sudden shift in the frictionless superfluid core, or a microscopic fracture in the stellar surface, can instantly alter the star's rotational speed by a fraction of a percent. In the translated audio, this event sounds like a DJ briefly dragging a hand across a spinning record, a sudden, complex hiccup in the rhythm. These sudden disruptions remind us that these are not simple, lifeless machines, but dynamic, evolving objects constantly reacting to immense internal pressures. The stuttering beat is a temporary window into the violent instability, hiding just beneath the surface of the perfect sphere. Even the most perfect cosmic clocks occasionally stumble, adding a brief moment of jagged unpredictability to their eternal song. Scientists rely on these auditory patterns for far more than just creating eerie, cosmic soundtracks. They are essential tools for measuring the very architecture of the galaxy. As the rhythmic pulses travel through the interstellar medium, they encounter vast, invisible clouds of ionized gas and dust. This interaction slightly delays the arrival of the lower frequency sounds compared to the higher frequency ones, stretching the signal out over time. By precisely measuring this auditory smearing, astronomers can calculate the exact amount of interstellar material the signal had to punch through to reach Earth. This subtle distortion of the beat acts as a cosmic yardstick, allowing us to map the density of the seemingly empty space between the stars. The amount of delay directly correlates to the exact distance between our telescopes and the spinning remnant. Take a slow, deep breath, feeling your chest expand, and consider how a slightly delayed rhythm can map the invisible structures of the void. The stuttering, stretched beats tell us not only about the star itself, but about the long, hazardous journey the light undertook across thousands of light years. The music of the pulsar carries the physical imprint of the galaxy it inhabits, written entirely in the subtle timing of its pulse. This unparalleled precision elevates these spinning remnants from mere astronomical curiosities to the most highly accurate cosmic clocks scattered throughout the universe. The steady ticking of a millisecond pulsar is actually more reliable and consistent than the most advanced atomic clocks ever constructed by human engineering. They are natural timekeepers, their rhythms governed by the unbreakable laws of angular momentum and extreme mass. Because their rotation is so massive and their structure so rigidly compressed, external forces struggle to alter their spin. A standard atomic clock on Earth is subject to tiny fluctuations in temperature, magnetic fields, or human error, requiring constant calibration. The cosmic metronomes, however, spin isolated in the freezing vacuum, immune to the trivial disruptions that plague our terrestrial instruments. This perfect timing allows researchers to utilize them as an absolute, unwavering baseline for measuring the passage of time across deep space. They serve as a permanent, reliable metronome against which all other cosmic events can be measured and tracked. The galaxy is effectively filled with these indestructible, hyper-accurate timepieces, ticking away the eons with flawless mathematical certainty. The reliability of these cosmic clocks is so absolute that even the slightest gravitational wave passing by can be detected as a microscopic shift in their steady ticking. When massive objects like black holes collide, they send ripples through the very fabric of space-time, stretching and compressing the universe as they pass. As one of these invisible waves washes over a pulsar, it temporarily alters the physical distance between the star and Earth. This momentary warping of space causes the rhythmic beat to arrive just a fraction of a millisecond earlier or later than mathematically predicted. By monitoring a network of these highly precise clocks scattered across the sky, astronomers can actually listen for the subtle, shifting delays caused by these gravitational tsunamis. The network acts as a galactic-scale microphone, waiting for the massive low-frequency rumble of colliding titans. It is a profound testament to the sensitivity of these natural instruments that they can detect the microscopic stretching of empty space itself. The steady ticking of the dead stars provides a silent background against which the most violent, invisible events in the universe can be measured and understood. They are the perfect, unwavering grid upon which the chaotic geometry of space-time is constantly redrawn. Over millions of years, however, even the most perfect cosmic clocks must eventually succumb to the slow, unrelenting drain of energy. The continuous sweeping of the magnetic beams and the emission of high-energy particles constantly siphon rotational momentum away from the star. The furious, dizzying spin of the newly born remnant is inevitably destined to slow, a gradual unwinding of the tightly coiled spring. As the rotation slows, the pitch of their cosmic song slowly drops, transitioning from a frantic, high-pitched whine to a steady thump, and eventually to a slow, deliberate knock. The sweeping beams lose their intensity, the magnetic fields weaken, and the dead star slowly begins to fade back into the absolute darkness from which it was born. It is a slow, quiet death, taking billions of years to complete its final unwinding. Eventually, the spinning will slow to the point where the magnetic forces can no longer generate the powerful beams of radiation, and the pulse will simply cease. The star will remain, a cold, silent sphere of hyper-compressed iron drifting invisibly through the freezing void. The hypnotic ticking will stop, the metronome will halt, and the celestial choir will lose another voice to the eternal silence of the deep dark. Any macroscopic object attempting to touch down upon this unyielding iron crust would meet an instantaneous and catastrophic end. The immense gravitational field would seize the object, accelerating it downward with such violence that the structural integrity of any known material would immediately shatter. Flesh, bone, and the most advanced synthetic alloys alike would be obliterated in a mere fraction of a second. Ultimately, the entire mass of the visitor would be violently smeared across the star's smooth exterior, compressed into an ultra-thin film. The invading matter would be crushed down into a microscopic layer barely a few atoms thick, permanently incorporated into the flawless, rigid lattice of the star. It is an environment of absolute physical subjugation, where the architecture of matter itself is forcibly flattened by the invisible weight of the dark. Looking closely at this sphere from a safe distance, the overwhelming gravity continues to warp our fundamental perception of physical reality. The pull is so phenomenally strong that even massless photons of light must fight an arduous uphill battle to break free from the surface. This immense struggle causes the outgoing light rays to bend into severe, unnatural arcs as they claw their way out of the gravity well. The escaping light also loses a significant portion of its kinetic energy during this desperate climb, causing its wavelength to stretch dramatically. This gravitational redshift means that whatever faint glow the star emits is perceived by our instruments as deeply, unnaturally reddened. It is a visual testament to an environment so heavy that it physically drags upon the fastest moving particles in the known universe. Long before this sphere cooled into its current state, its birth was defined by a flash of unfathomable searing heat. In the immediate aftermath of the initial stellar collapse, the core temperature spikes to levels that make the centre of our solar system seem freezing by comparison. The newly forged remnant becomes a crucible burning at billions of degrees, radiating an inferno of raw, blinding thermal energy. At these incomprehensible temperatures, the newly born remnant exists as a boiling, chaotic sphere of highly unstable physics. The heat is so extreme that it triggers the spontaneous generation of entirely exotic subatomic particles within the core, bubbling violently up through the superdense fluid. It is a temporary, violently energetic phase that marks the star's chaotic transition from a burning giant to a crushed remnant. Take a moment to sink deeper into whatever surface is supporting you, feeling the comfortable, ambient warmth of your resting environment. Far from this safety, the young star spends its first few moments screaming its thermal energy into the surrounding space in a desperate attempt to stabilize. This initial heat wave is a terrifying burst of cosmic power, a brief, blinding flash preceding a long, dark eternity. Despite the staggering intensity of this initial inferno, the stellar corpse possesses no internal mechanism to sustain the fire. Because all nuclear fusion has completely ceased, the immense reserve of thermal energy simply bleeds away into the endless cold of the surrounding vacuum. The cooling process begins almost immediately, initiating a slow and irreversible decline from blazing incandescence down toward absolute zero. Over the passage of eons, the blistering surface temperature steadily plummets, dropping down the spectrum from glaring white to a dull, dim red. Eventually, the remnant radiates away the last of its visible heat, dipping below the threshold of human optics and sinking into total obscurity. The star becomes entirely invisible to standard telescopes, a ghost haunting the deep space it once vibrantly illuminated. This thermal death transforms the once raging crucible into a frozen, inert marble suspended eternally in the cosmic dark. Stripped of its warmth and light, it drifts silently through the galactic arms, completely undetectable unless one knows exactly where to look. The universe is littered with these frozen dead spheres, ancient monuments to a fiery past that has long since burned away. Curiously, the transition into a frozen state does not mean the surface of the iron shell is entirely devoid of geological features. Tremendous internal stresses acting upon the solid crust can force the rigid material to buckle and rise, creating miniature mountain ranges across the metallic landscape. These tiny ridges represent the only topographical variations on an otherwise flawlessly smooth, polished sphere. Yet, The tyrannical force of the downward pull strictly dictates the maximum height these cosmic peaks can ever hope to achieve. If a ridge attempts to push upward by more than a tiny fraction of an inch, the sheer weight of its own mass causes it to instantly collapse back upon itself. Thus, the tallest mountains on this hyperdense world measure barely a few millimeters in height, microscopic wrinkles on a metal canvas. Climbing the summit of one of these millimeter-tall peaks would still require overcoming a gravitational hurdle equivalent to scaling our world's tallest terrestrial mountains. The amount of energy required to lift a single atom off the crest of these tiny ridges is mathematically staggering. They stand as perfectly flat, hyper-compressed monuments to the inescapable crushing authority of the star's gravitational field. This delicate miniature topography is occasionally shattered by sudden and catastrophic geological failures deep within the solid outer shell. As the dead star slowly spins down over millennia, the changing centrifugal forces create unimaginable tension across the rigid iron lattice. Eventually, the structural strain becomes too great, and the unyielding crust violently snaps, resulting in a devastating starquake. Unlike terrestrial earthquakes, the energy released by the fracturing of this hyperdense material is channeled directly into the extreme electromagnetic spectrum. The sudden shearing of the massive magnetic fields anchored in the crust generates a blinding momentary flash of pure high-energy radiation. These violent ruptures unleash staggering bursts of invisible X-rays, briefly outshining entire galaxies in the highest energy bands. Allow your breathing to slow down, tracing the gentle rise and fall of your chest as you picture this distant, violent snapping. This sudden release of energy sends devastating shock waves rippling through the dark, briefly illuminating the surrounding vacuum before plunging the region back into shadow. It is a harsh reminder that even the most frozen, seemingly inert objects in the cosmos are capable of unleashing spontaneous destruction. Beyond the solid surface, the immediate environment is dominated by a relentless, outward-flowing blizzard of expelled subatomic matter. The furiously rotating magnetic lines physically drag surrounding particles along for the ride, accelerating them outward into the dark at terrifying velocities. This continuous expulsion creates a fierce, driving wind composed entirely of highly charged ions and lethal free electrons. The velocity of this particle storm is incomprehensible, reaching speeds that brush right up against the ultimate cosmic speed limit. As the wind screams outward, it carries away a significant fraction of the star's remaining kinetic energy, slowly dragging the entire rotation to a halt. It acts as a massive, invisible parachute, generating friction against the surrounding vacuum and continuously bleeding the system's power. Any stray material unfortunate enough to drift too close is instantly caught in this maelstrom and blasted into pure oblivion. The outflowing wind carves a massive hollow cavity into the surrounding interstellar medium, pushing back the cold gas and creating an isolated bubble of extreme radiation. It is a permanent, violent storm blowing endlessly outward from the otherwise dead, silent core. Closer to the star, the invisible magnetic force grows so concentrated that it begins to interfere with the fundamental properties of empty space itself. In these extreme conditions, the vacuum is not truly empty, but rather a simmering quantum field reacting wildly to the overwhelming magnetic stress. The intense field lines force the virtual particles popping in and out of existence to align perfectly with the magnetic flow. This bizarre quantum alignment turns the empty space around the star into a refractive lens that physically twists any light passing through it. As the photons emitted by the surface struggle outward, their electrical fields are forcibly polarized, twisted into a uniform orientation by the quantum storm. The light becomes strictly ordered, carrying the invisible fingerprint of the magnetic field embedded directly in its waveform. Astronomers studying this highly ordered light can literally read the exact shape and intensity of the invisible forces choking the star. It is a phenomenon where the abstract mathematical laws of quantum mechanics become macroscopic, visibly altering the radiation cast into the dark. the magnetic grip is so absolute that it physically reshapes the trajectory and orientation of every single photon trying to flee. The sheer strength of this upward magnetic pull eventually overcomes even the terrifying crushing downward force of the star's gravity. Along the magnetic poles, the electrical tension grows so severe that it physically strips individual electrons directly off the iron atoms making up the rigid crust. These liberated particles are violently yanked upward, ripped from their metallic bonds and cast into the void above. This continuous extraction of matter generates a thin, fiercely hot atmosphere of pure ionized gas hovering directly over the frozen surface. The liberated electrons are whipped into a frenzy by the rotating fields, cascading and colliding to form a blindingly bright shell of glowing plasma. It is a surreal juxtaposition, a blazing, chaotic atmosphere suspended precariously over a completely dead, frozen landscape. Sink into the quiet heaviness of your relaxed muscles, contrasting your calm physical state with the chaotic, tearing violence occurring at the poles. The magnetic extraction process never ceases, continually feeding the glowing plasma clouds that eventually become the sweeping beams of radiation defining the star. The remnant is slowly cannibalizing its own solid crust, converting its physical mass into the furious energy broadcast across the galaxy. Plunging into this magnetically suspended atmosphere would expose an observer to an environment of absolute, unmitigated hostility. The plasma is not merely hot gas. It is a chaotic, blinding soup of high-energy particles moving at relativistic velocities and emitting lethal doses of hard radiation. It is a churning, luminous ocean of pure kinetic fury, crackling incessantly with the violent snapping of invisible field lines. Navigating through this tempest would feel akin to flying straight into the detonation of an atomic weapon that never stops exploding. The ambient radiation levels would fry any conceivable shielding, while the constant bombardment of relativistic electrons would shred the molecular bonds of any solid structure. The visual experience would be a blinding, featureless whiteout, overwhelmed completely by the sheer intensity of the energy emissions. This raging plasma storm represents the final, insurmountable barrier protecting the frozen, silent secrets of the hypercompressed core beneath. It is the ultimate forge of extreme physics, where the rules of the universe are pushed to their absolute breaking points in a continuous, furious display. Only by peering through the microscopic gaps in this blinding tempest can we even begin to understand the heavy, silent titan lurking below. While we may never physically penetrate the blinding tempest to see the heavy, silent titan lurking below, we can observe the eerie influence it exerts over the surrounding void. Surprisingly, the hunt for alien worlds did not begin with the warm yellow stars we often associate with life, but instead led us into the shadows of these dead remnants. The very first exoplanets ever confirmed by humanity were found circling a pulsar, proving that planetary systems can endure or even arise from the ashes of a star's violent death. These worlds do not know the comfort of a golden dawn or the soft transition of a terrestrial twilight. Instead, they drift through a graveyard of a light, tethered to a master that no longer burns with the fire of fusion. The discovery of these pulsar planets shattered our most basic assumptions about the habitability of the universe and the longevity of planetary matter. These dark satellites exist as lonely outposts in a silent void, witnessing the rhythmic, strobe-like flicker of a cosmic beacon that has outlived its own life cycle. They are the ghosts of a solar system that died and was somehow reborn in the freezing dark, standing as silent witnesses to the resilience of matter against the most violent forces in nature. Instead of the gentle, life-giving warmth of a main-sequence star, these desolate worlds are subjected to a constant, searing bombardment of high-energy radiation. The sunlight provided by their host is a lethal cocktail of X-rays and gamma rays that would instantly dismantle the molecular bonds of any organic life we can imagine. The surface of such a planet is likely a sterile wasteland, scorched by the unrelenting fury of the pulsar's sweeping beams as they pass over the terrain hundreds of times per second. Deep within the radioactive clouds of an ancient supernova remnant, scientists believe these strange worlds may have been forged from a chaotic debris disk. After the massive star exploded, a thick ring of heavy elements and stellar fragments remained, swirling around the newly formed core like a funeral shroud. Over millions of years, gravity slowly pulled this scrap together into rocky spheres, creating a second generation of planets from the radioactive remains of the first. This structure suggests a cycle of cosmic reincarnation, where the violent death of a star provides the raw materials for a dark new solar system. These are not survivors of the explosion, but children of the blast, born into a universe that had already tried to destroy their parent through the fury of a supernova. Notice how your body rests in the calm air of your room, while these worlds were assembled in a vacuum filled with the cooling embers of a stellar catastrophe. They represent a second chance at existence, albeit one defined by the cold, rhythmic precision of an undead master. Picture a world composed almost entirely of crystalline carbon, a gargantuan diamond suspended in the void and shimmering with a cold internal light. This planet orbits so close to its hyperdense host that a full year passes in a matter of mere Earth hours, a frantic race through space that defies terrestrial logic. The gravitational pull from the pulsar is so extreme that the planet's internal structure is crushed into a state of absolute rigidity, transforming common elements into precious gemstones. If we were to look closer, we would see a world where the very ground is a gemstone, reflecting the sharp, rhythmic flashes of the star it serves with every passing second. It is a world of crystalline perfection and extreme orbital speed, a jewel tethered to a master that is equally compressed and unyielding in its grip. The sheer pressure of its existence has turned its entire mass into a singular, glittering monument to the physics of the deep dark. This diamond world spins in a state of high-speed servitude, its beauty forged by the very forces that would destroy a less resilient world. This cosmic structure often involves a parasitic relationship, where the pulsar acts as a gravitational leech, slowly siphoning away the very essence of a nearby companion star. The intense pull of the heavy, silent Titan grabs streamers of gas from its neighbour, creating a glowing bridge of matter that spirals down toward the spinning core. This stolen material is compressed and accelerated as it falls, releasing blinding flashes of energy that illuminate the local space like a violent flickering torch. The companion star is gradually drained of its mass, becoming a withered, distorted husk of its former self as its outer layers are stripped away by the invisible thief. It is a slow-motion consumption, a stellar feeding that can last for millions of years before the neighbour is entirely depleted of its substance. The pulsar grows more energetic and vibrant, fed by the literal lifeblood of the star that was once its equal in the void. As you sink into the stillness of your rest, imagine the silent, relentless tug of gravity drawing the light from one star into the heart of another. Surprisingly, the universe uses this cannibalistic feeding process to actually force the pulsar to spin faster and faster, like a child pushing a merry-go-round. As the stolen gas strikes the surface of the neutron star, it transfers its orbital momentum to the core, acting as a massive, continuous mechanical push. Eventually, the pulsar achieves speeds of hundreds of revolutions per second, transforming from a slow, methodical ticker into a hyper-fast millisecond beacon. The energy of the fallen star is effectively recycled into kinetic fury, pushing the physical limits of how fast a solid object can rotate without flying apart. This spin-up phase creates a star that is essentially reborn, gaining a second life of intense activity through the systematic destruction of its partner. It is a mechanical resurrection fueled by theft, resulting in a clock that ticks with a frequency that is almost musical in its rapidity. Through this process, the pulsar regains its youth and power, becoming a blindingly fast sentinel in the graveyard of its own making. If we were to look closer at these systems, we would understand why astronomers have given these predatory stars a chilling name: black widows. This title reflects their tendency to slowly vaporize and destroy the very companions that help them achieve their incredible millisecond speeds. Once the pulsar is spun up and the feeding is largely complete, its intense radiation and fierce particle winds begin to scour the remaining mass of its partner. The companion star is not just being drained, it is being eroded by the very energy it helped create through its own sacrifice. It is a grim, beautiful cycle where the star's rebirth as a fast-spinning beacon spells the ultimate doom for its closest neighbour in the dark. As you feel the weight of your own limbs sinking into relaxation, imagine a star being slowly dissolved into light by the rhythmic heart of its closest companion. The Black Widow star stands alone in the end, a fast-spinning ghost powered by the memory of its fallen mate. The orbits of these companion planets and husks are often so perfectly circular that they defy standard models of how solar systems usually form. Normally, the incredible violence of a supernova and the subsequent death of a star would kick any nearby objects into eccentric, elongated paths. However, these worlds follow tracks that are almost mathematically flawless, tracing circles with a precision that seems engineered rather than accidental. This perfection suggests that the process of siphoning gas and the resulting gravitational drag acted as a cosmic stabilizer, smoothing out the planetary paths over eons of interaction. It is a rare moment of geometric calm in a system otherwise defined by extreme radiation and gravitational theft. The chaotic energy of the pulsar's birth has been refined into a series of perfect silent loops that never deviate from their established course. Notice the stillness of your own breath as you contemplate these dark worlds tracing their perfect, silent circles around the ticking core. Any atmosphere that might attempt to cling to the surface of these worlds would be stripped away instantly by the fierce pulsar wind sweeping through the system. The constant stream of relativistic particles and high-energy photons acts like a molecular sandblaster, scouring the planetary surfaces clean of any protective gas. These are worlds of bare, irradiated rock and exposed minerals, forever denied the softening touch of clouds, wind, or air. The sky above them is a permanent airless void, offering a crystal-clear and terrifying view of the rhythmic, flashing beacon that dominates their existence. Without a magnetic field or a thick atmosphere to shield them, the very rocks are subjected to a constant bombardment that may even change their chemical composition over time. They are skeletons of planets, stripped of their vanity and left to orbit their dead master in a state of naked geological purity. On these worlds, the very concept of weather is replaced by the relentless invisible rain of subatomic particles from the star. A few rare systems feature two of these extreme objects locked in an intricate gravitational waltz, dancing around one another in the deep, silent dark. These binary pulsars are perfectly matched in their intensity, their rhythmic beams overlapping and intersecting as they spiral closer together through the fabric of space-time. Their movements are so precise that they act as a grand natural laboratory for testing the most fundamental laws of the universe. As they orbit, they slowly bleed away energy, drawing ever nearer in a beautiful doomed embrace that will eventually end in a cataclysmic merger. For now, however, they continue their silent, measured dance through the shadows of the undead, two lighthouses spinning in a perfect synchronized rhythm. It is the final grand performance of the deep dark, where the heaviest titans of the universe move with the grace of ghosts before the eventual silence. Within this gravitational waltz, we find the most profound evidence of the universe's order, hidden in the heart of its most extreme remnants. This profound evidence of the universe's order is carried through the dark by particles of light that began their journey across the void long before the first human ancestor looked up at the night sky. A single photon, finally striking the lens of a modern telescope, has been travelling in a straight and lonely line for hundreds of thousands or even millions of years. It departed its hyperdense parent at a time when the Earth was dominated by species long extinct, cutting through the silence of space while continents slowly drifted into their current shapes. Consider the sheer endurance of such a tiny messenger, crossing vast gulfs of nothingness without ever hitting a single atom of dust until it reaches our world. It carries the energy of a star that vanished eons ago, a remnant of a past so distant that the very concept of humanity was still a biological impossibility. This light is a ghost, a physical survivor of an ancient era that has reached us only now, bridging the impossible gap between the dawn of life and the peak of our scientific curiosity. As you feel the subtle rhythm of your own breath, let your mind wander to that unwavering beam of light moving through the vacuum at the ultimate speed. It has outlived empires, survived the cooling of planets, and ignored the birth of countless minor stars just to deliver its message to the present moment. We're not merely looking at the sky, we're receiving a direct physical touch from the deep history of the cosmos. Deep within the structure of these signals lies a map of the ancient universe, allowing us to peer through the layers of time as if they were pages in a dusty cosmic ledger. Because these pulses are emitted with such inhuman regularity, any deviation we detect becomes a clue to the layout of the space between here and the source. By analysing how the light has been influenced during its million-year journey, astronomers can reconstruct the distribution of matter as it existed in the distant past. This process transforms every pulsar into a deep space probe that has already completed its mission, delivering a report on the density and composition of the galaxy's long-forgotten regions. We see the shadows of gas clouds that may have dissipated long ago and the echoes of magnetic fields that have since shifted their orientation. It is a form of celestial archaeology, where the artifacts are not buried in the ground but are encoded in the arrival times of radio waves. If we were to look closer, we would see that the universe is not a static picture, but a dynamic, evolving history book that is constantly being broadcast into the dark. Each pulse is a data point in a grand survey of the prehistoric Milky Way, charting the hidden architecture of a world we can never visit in person. We're effectively mapping the skeleton of the galaxy using the light of its most resilient and ancient ghosts. Surprisingly, the seemingly empty spaces between stars are filled with hidden ghosts of their own, revealed only when the pulse of a pulsar encounters a stray cloud of gas or dust. Every time a burst of radiation is delayed, even by a fraction of a microsecond, it signals the presence of an invisible obstacle lurking in the freezing void. These interstellar clouds are often too cold or too thin to be seen by ordinary means, yet they cannot hide from the rhythmic, penetrating beams of a spinning remnant. The interaction between the light and the gas causes a phenomenon known as dispersion, where different frequencies of the signal arrive at our detectors at slightly different times. This auditory smearing of the cosmic song acts like a chemical analysis, revealing the exact temperature and ionization of the gas the pulse had to penetrate. What appeared to be a featureless void is suddenly populated with complex structures, turbulent eddies, and massive filaments of hydrogen stretching across the dark. Notice the weight of your body as it sinks into a state of total stillness, mirroring the quietude of the vast interstellar gulfs where these clouds drift. The pulsar acts as a cosmic sonar, pinging the contents of the galaxy and listening for the subtle delays that betray the presence of hidden matter. Through these rhythmic echoes, we have learned that the space between stars is a rich, complex environment, teeming with the raw materials of future suns and planets. The steady degradation of their spin provides a reliable timeline for estimating the exact age of the stellar remnant. This structure is effectively a self-winding clock that is slowly, predictably running down as it bleeds energy into the surrounding space. By measuring the current rate of rotation and comparing it to how quickly that rotation is slowing, astronomers can work backward to the exact moment the original star met its violent end. This calculation allows us to date these cosmic corpses with a precision that few other methods can match, placing them accurately within the chronology of the galaxy. We can identify which pulsars are energetic youths still glowing with the heat of their birth, and which are ancient, weary sentinels nearing the end of their long rhythmic lives. The spin-down rate is a physical record of the star's history, etched into the very mechanics of its rotation. If we were to look closer at this unwinding, we would see the slow loss of kinetic power as the magnetic fields drag against the vacuum of space. It is a graceful, inevitable decline, a winding down of a celestial spring that has been ticking since the dawn of an earlier age. This chronological data helps us understand the birth rate of massive stars and the frequency of the cataclysms that populate the universe with these spinning ghosts. Long ago, ancient cultures across the globe looked up to witness the spectacular birth of the most famous pulsar known to modern science. In the 11th century, astronomers recorded the sudden appearance of a guest star so bright it remained visible even in the glare of the noon sun. This blinding flash was the death rattle of a massive star, a supernova that briefly outshone every other object in the night sky. Those ancient observers could not have known that they were witnessing the creation of a hyperdense engine that would still be spinning 1,000 years into their future. They saw the light of the explosion, the final scream of a dying titan, and recorded its position with a precision that modern scientists still rely on to navigate the stars. This historical record creates a profound bridge across a millennium, connecting the primitive wonder of the past with the sophisticated technology of our present era. The star they saw has since faded into a beautiful, tangled wreckage of glowing gas, leaving behind only the rhythmic heartbeat we study today. It is a humbling thought that the same object once marvelled at by scholars in silk robes is now being monitored by silicon sensors and orbiting satellites. The pulsar serves as a physical thread, sewing together the disparate eras of human observation into a single, continuous narrative of discovery. Today, we watch the spinning core that remains, connecting our modern observations with those historical records in a unique scientific partnership. This structure of evidence allows us to track the evolution of a single object over 1,000 years, witnessing how the energy of the explosion has matured into the steady pulse of the remnant. We can compare the drawings and descriptions of the ancient observers with the high-resolution maps generated by our current radio and X-ray observatories. This continuity of observation is incredibly rare in the field of astronomy, where most processes take place over timescales far beyond the lifespan of any civilization. The pulsar offers a unique opportunity to witness the final results of a specific dated event, confirming our theories about the life cycles of the most massive stars. We're effectively peering through a telescope that has been manned by a relay of observers spanning dozens of generations of human history. Ground yourself in the present moment by noticing the soft, steady rhythm of your own heart, while your mind reaches back through the centuries to those ancient watchers. We are the current guardians of this long-term study, adding our own precise measurements to a ledger that was started by our ancestors under a different sky. This connection to the past reinforces our place in the cosmos, showing that even the most extreme events can be understood through patient, multi-generational observation. This charting process ensures that these beacons serve as vital historical markers, mapping the life cycles of massive stars across billions of years of galactic time. By studying pulsars at different stages of their evolution, we can piece together the entire biography of a giant star, from its hydrogen-burning youth to its explosive middle age. They are the data points that allow us to build a comprehensive model of stellar evolution, illustrating the inevitable fate of the most luminous objects in the sky. Every pulsar we discover acts like a timestamp in the grand story of the Milky Way, telling us when and where the most massive stars have lived and died. They reveal the regions of our galaxy that were once nurseries for giants, and the graveyards where those giants now rest in hyper-compressed rhythmic silence. This mapping process shows us that the galaxy is a dynamic, living system that recycles its matter through a continuous cycle of birth and catastrophe. If we were to look closer, we would see that the population of pulsars provides a census of the most energetic events in our cosmic neighbourhood over the last several billion years. They are the permanent records of the explosions that enrich the universe with heavy elements, providing the very building blocks of life itself. By charting their lives, we are ultimately charting the history of the materials that allow us to exist, breathe, and wonder at the night sky. The signals we capture today carry the faint, stretched fingerprints of the universe's expansion since the light was first emitted from the source. Because the space through which the light travels is constantly growing, the pulses are physically stretched, a phenomenon known as cosmological redshift. This expansion acts on the very timing of the pulse's beat, causing the intervals between the flashes to arrive slightly further apart than when they were first broadcast. This subtle stretching of time and light provides a direct measurement of how much the universe has expanded during the signal's million-year journey through the void. It is as if the light has been marked by the very fabric of space it traversed, carrying an encoded message about the growth of the entire cosmos. Astronomers can use this data to refine our understanding of the rate at which the universe is accelerating, using the pulsar as a cosmic yardstick. Picture the vast, invisible stretching of the space between galaxies occurring in every direction, even as you remain perfectly still in your own world. The pulse you detect today is a relic of a smaller, more compact universe, arriving in a present that has expanded significantly since the photon began its flight. This connection between a spinning star and the overall scale of the cosmos is one of the most profound realizations in physics, linking the tiny to the infinite. Some of these hyperdense remnants have been spinning silently for over 10 billion years, acting as ancient sentinels from the dawn of the cosmos itself. These are the survivors of the very first generations of stars, born when the universe was less than a quarter of its current age. They have drifted through the vacuum since before our planet was formed, witnessed the birth of the galaxy, and survived the collisions of ancient stellar systems. Their longevity is a direct result of their incredible density and the relatively slow rate at which they lose their massive rotational momentum. These ancient sentinels are among the oldest individual objects we can identify in the sky, carrying the secrets of a primordial era when the universe was more crowded. They are the true elders of the galaxy, sitting in hyper-compressed silence while entire generations of younger stars flare up and vanish in an instant. Notice the deep, heavy relaxation spreading through your limbs, a stillness that mirrors the patient, 10 billion year endurance of these ancient ghosts. They have seen the entire history of our corner of the universe, and they will likely continue to pulse long after the current stars have grown cold. They stand as a bridge to the very beginning of time, a physical link to the conditions that existed shortly after the universe was born. Their incredible longevity ensures that they will continue to flash their rhythmic signals long after our own sun has burned out and the Earth has ceased to exist. Our sun is a middle-aged star with perhaps 5 billion years of fuel remaining before it transitions into a white dwarf and slowly fades into the dark. By the time our solar system has become a cold and desolate place, the most resilient pulsars will still be spinning, still beating their time into the void. They represent the ultimate endurance of matter, a state of existence that can persist for trillions of years in a stable and hyperdense configuration. Long after the era of star formation has ended and the galaxy has grown dim, these rhythmic lighthouses will provide the final flickers of energy in a cooling universe. They are the last sentinels of the light, the final guardians of the momentum that once powered the great nebulas and stellar nurseries of the past. This perspective offers a strange sense of comfort, a realization that something we observe today will endure far into a future we cannot possibly conceive. The rhythm we capture with our radio telescopes is a heartbeat that will outlast humanity, outlast our planet, and outlast the very star that gives us life. It is the final, enduring echo of the universe's vibrant youth, continuing to pulse in the deepening silence of the infinite night. the deepening silence of the infinite night is not always as empty as it appears, for hiding within the dark are the invisible leviathans of the cosmos. Known as magnetars, these rare and extreme variations of the pulsar family boast the most intense magnetic fields ever documented in the known universe. While a standard neutron star is already a magnet of staggering proportions, these specialized remnants push the laws of physics into a realm of pure magnetic tyranny. The sheer magnitude of their influence is almost impossible to quantify, as they possess fields quadrillions of times stronger than the one that guides a humble compass needle on Earth. This structure does not merely influence nearby particles, it defines the very geometry of the space it occupies, twisting the vacuum into a state of permanent tension. Only a handful of these monsters have been identified in our galaxy, making them some of the most elusive and terrifying objects in the celestial bestiary. They represent the absolute limit of magnetic concentration, a pinnacle of stellar evolution, where force replaces light as the primary characteristic of the star. To find such an object is to discover a place where the fundamental forces are no longer subtle, but act with a direct and overwhelming authority. They are the unseen masters of the local void, ruling over matter and space with an invisible, unyielding grip that binds the very fabric of existence. They exist as rare relics of the universe's most violent births, surviving only as long as their magnetic hearts can sustain the immense pressure. Once discovered, they offer a window into a domain of physics that remains inaccessible to any terrestrial laboratory or human-made experiment. Their presence ensures that the galaxy remains a place of mystery and invisible power, hidden within the deepening silence. Beyond the limits of our planetary defences, the reach of these invisible leviathans is so vast that their presence near our world would have catastrophic consequences for our technological civilization. If a magnetar were to be placed merely halfway between the Earth and the Moon, its magnetic field would be strong enough to instantly erase the data on every single credit card on our planet. This is not due to any physical touch or radiation, but simply the result of the sheer density of the magnetic lines of force sweeping through our atmosphere. Such a field would physically pull the iron from your blood if you were too close. But even at a distance of hundreds of thousands of miles, its invisible grip would reorganize the atomic structure of most magnetic storage media. This structure reveals how the fundamental forces of the universe can become macroscopic weapons when concentrated in such a hyperdense core. It serves as a stark reminder of the fragile nature of our electronic world when compared to the raw, unbridled power of a dead star. We exist in a pocket of magnetic calm, unaware of the silent giants that possess the power to dismantle our tools from across the lunar void. This distance provides a safety that we often take for granted in our daily lives. Yet, the existence of such fields proves that even the most distant objects can have an invisible, profound relationship with the technology we rely on every day. Our modern world is built on the assumption of a stable magnetic environment, a luxury that the rest of the cosmos does not always share. The magnetar stands as a potential disruptor of that stability, a cosmic agent of chaos that could reach across the void to rewrite our digital history. It is a humbling thought that our global information network could be silenced by the mere proximity of a city-sized star. Deep within this suffocating magnetic shroud, the laws of motion are dictated entirely by the invisible architecture of the field lines. These magnetic threads act as cosmic funnels, capturing any stray charged particles in the vicinity and forcibly dragging them toward the star's magnetic poles. As these particles are accelerated to near-light speeds along the twisted pathways, they begin to vibrate with such intensity that they emit the powerful beams of radiation we detect on Earth. This structure ensures that the energy of the star is not cast out randomly, but is instead focused into precise lethal channels of light and radio waves. The resulting beams are not mere flickers, but are the concentrated screams of matter being torn apart by magnetic tension as it enters the polar regions. Notice how your body rests in the stillness of your room, while these particles are being whipped through a magnetic labyrinth at velocities that defy human comprehension. The Pulsars lighthouse effect is effectively a side effect of this relentless magnetic herding, a visual manifestation of a force that refuses to let anything move freely. It is a process of total control, where the invisible threads bind the local space into a rigid glowing harness. In this domain, the very idea of a free particle is an impossibility, as every electron is an unwilling passenger on a magnetic roller coaster. Particles that would otherwise drift aimlessly through the void are here pressed into service, forced to announce the star's presence to the rest of the universe. They trace out the shape of the invisible Leviathan, mapping the field lines with their own brilliant dying light. It is a spectacle of total subjugation, where the star's magnetic will is the only law that matters. This structure of magnetic dominance extends into the very solid crust of the star itself, subjecting the hypercompressed iron to stresses that even neutronium cannot withstand. The magnetic field lines are often anchored deep within the stellar interior, and as the star rotates, these lines become twisted and knotted like giant ropes under extreme tension. Eventually, the magnetic pressure becomes so immense that it physically pulls on the solid crust, causing it to buckle and fracture in a violent display of geological failure. When the crust finally gives way, it triggers a starquake of such magnitude that the resulting release of energy is almost incomprehensible to the human mind. This sudden rupture uncurls the knotted magnetic field lines, unleashing a blindingly bright flare of high-energy gamma radiation into the surrounding void. These bursts are the most powerful explosions seen in the universe since the Big Bang, occurring on an object no larger than a typical terrestrial city. The sheer density of the energy released during these crustal snaps can briefly outshine the combined light of an entire galaxy. It is a moment where the invisible tension of the magnetic field becomes a visible, destructive force, tearing the very surface of the star asunder. The resulting shockwave carries the signature of the star's internal struggle, broadcasting the news of its injury across the vast reaches of space. In the aftermath of such an event, the star slowly settles back into its rhythmic routine, but the scars of the rupture remain etched into its unyielding surface. These flares are the heartbeat of the magnetar's violent life, marking the steady erosion of its magnetic reserves. They are the most dramatic evidence we have of the constant battle between the star's gravity and its own internal forces. Throughout history, the stars have been seen as distant and unreachable, but we found a chilling example of their power in the flare that reached Earth in late 2004. Originating from a magnetar located over 50,000 light-years away, a single burst of gamma radiation hit our planet with such force that it temporarily altered the chemical composition of our upper atmosphere. For a fraction of a second, the night side of the Earth was bathed in radiation, as intense as if the sun had suddenly flared in the middle of the night. This pulse was so energetic that it saturated the sensors of every X-ray satellite in orbit, effectively blinding our eyes in space for several minutes. This structure of the event highlights the terrifying reach of a magnetar's death throes, capable of reaching across half the galaxy to brush against our world. Despite the immense distance, the energy that arrived was still potent enough to compress our planet's magnetic shield and disturb the flight of low-frequency radio waves. Sink into the quiet heaviness of your relaxed limbs, realizing that a star located on the other side of the Milky Way once physically reached out and touched the very air you breathe. It was a silent, invisible wave that reminded us of our profound vulnerability to the giants lurking in the deep dark. Even across the impossible gulfs of space, the most extreme events can find a way to make their presence felt in our quiet home. The 2004 event remains the most powerful flash of light ever recorded from outside our solar system, a reminder that the universe is far more interconnected than we usually perceive. It proved that a city-sized object could influence the environment of an entire planet from tens of thousands of light-years away. This realization shifted our understanding of cosmic safety, showing that the deep dark is never truly empty or disconnected from our lives. Surprisingly, the magnetic field around a magnetar is so dense that it actually begins to alter the fundamental behavior of empty space itself. In these extreme conditions, the vacuum is no longer a simple void, but instead takes on the properties of a physical crystal through a bizarre quantum effect known as vacuum birefringence. As light passes through this magnetically choked space, it is forced to split and travel at different speeds depending on its specific polarization. This structure effectively turns the vacuum into a refractive lens, bending and twisting the path of any photon that dares to cross the magnetic field lines. It is a phenomenon that only occurs at the absolute limits of physics, where the invisible threads of the field become so tightly packed that they occupy every available coordinate of space. This quantum distortion provides a direct way for astronomers to see the invisible field, as the polarization of the light carries the signature of the vacuum struggle. It reveals a universe where the distinction between nothing and something begins to blur under extreme pressure and magnetic intensity. The space around the star becomes a physical participant in the star's energy, acting as a medium that reshapes the very nature of light. We are forced to reconsider the emptiness of the void when the strongest fields can turn a vacuum into a solid-like barrier for light. This quantum interaction is one of the most exotic predictions of modern science, and the magnetar is the only natural laboratory where it can be observed. It shows that space is not just a stage for the stars, but is itself a material that can be warped and manipulated by force. The very fabric of the cosmos is here revealed to be a fragile and reactive substance, susceptible to the magnetic tyranny of the leviathans. In the chaotic environment immediately surrounding the star, one would see a web of glowing, twisted ropes made of pure energy. These are the magnetic field lines, rendered visible by the sheer density of the particles and radiation they trap and manipulate. As the magnetar rotates, these ropes become hopelessly entangled, winding around each other until the tension reaches a breaking point. When these lines eventually snap and reconnect, they release sudden, violent bursts of energy that ripple through the local space like a whip. This structure of reconnection is the primary engine behind the star's persistent, high-energy activity, constantly recycling magnetic tension into heat and light. The snapping of a single one of these invisible ropes releases more energy than millions of nuclear weapons detonating simultaneously. It is a process of constant, violent reorganization, where the star is perpetually trying to shed its magnetic burden. Picture these brilliant, snapping threads of force as they whip through the vacuum, creating a landscape of light and shadow that changes with every millisecond. The star is effectively a prisoner of its own field, lashed by ropes of energy that define its every movement and shape the emissions that eventually reach our telescopes. These energy ropes act as the primary conduits for the star's immense power, carrying the heat of the core out into the surrounding void. They are the physical manifestation of the invisible threads that bind the local space, a glowing cage that keeps the star in a state of permanent agitation. In this environment, the very concept of peace is an impossibility, as the energy must always find a way to escape the magnetic knot. The radiation emitted by these magnetic snaps is so intense that it possesses the power to blind satellite sensors in orbit around our planet from vast distances. When a magnetar unleashes its energy, the resulting wave of hard X-rays and gamma rays acts like a cosmic flashbulb, overwhelming the delicate electronics designed to map the stars. These sensors are built to detect the faint whispers of distant galaxies, and the sudden roar of a magnetar is enough to saturate their circuits beyond recovery. This structure of emission ensures that for the duration of the flare, the magnetar is the only thing the universe is allowed to see in those high-energy bands. It is a total temporary dominance of the electromagnetic spectrum, a shout that drowns out the quiet conversation of the rest of the cosmos. As your breathing slows and your body remains still, consider the irony of a dead star being the brightest object in the sky to the eyes of our machines. These pulses carry such a high concentration of energy that they bypass the normal laws of astronomical observation. They do not merely provide data, they demand attention by physically overloading the tools we use to understand the heavens. It is a raw, unmitigated display of force that temporarily resets our understanding of what a single, celestial object is capable of producing. The data gathered during these brief moments of blinding light is among the most precious in all of astrophysics. It reveals the final limits of matter and energy, providing a glimpse into a world where the rules of the universe are pushed to their absolute breaking points. Despite the damage they can cause to our senses, these flares are the primary way we learn about the giants lurking in the dark. Locked within the mechanics of these invisible leviathans lies a paradox of time, for these most powerful of stars are also among the shortest lived. Because they bleed energy at such a staggering rate through their magnetic snaps and radiation flares, their extreme magnetic fields decay much faster than the star itself cools. A magnetar remains active and dangerous for only a relatively brief period of about 10,000 years before its magnetic reserves are finally exhausted. This structure of rapid decline means that the magnetars we see today are all cosmic newborns, flashes of brilliance that will vanish in the blink of an eye on a galactic timescale. Compared to the 10 billion year lifespan of a typical star, the life of a magnetar is a fleeting, violent scream in the dark. They represent a high-energy phase that consumes itself through its own intensity, a fire that burns too bright to last. This short duration makes them incredibly rare, as most have already passed through this stage and settled into a quieter existence. We are catching them in a rare moment of peak instability, witnessing a transition that is as brief as it is spectacular. They are the temporary monsters of the galaxy, leaving behind a legacy of intense radiation before they retreat into a long, cold silence. Every magnetar we discover is therefore a rare find, a snapshot of a violent process that is nearly over before it has truly begun. They are the shooting stars of the high-energy universe, providing a brief but intense display of power before fading away. This ephemeral nature adds to their mystery, making them one of the most prized targets for modern astronomical surveys. Once their incredible magnetic energy is finally spent, these invisible leviathans undergo a quiet transition into ordinary, unremarkable neutron stars. The violent snapping of the magnetic rope ceases, the devastating gamma-ray flares fall silent, and the star begins a long, slow cooling process that will last for eons. It effectively hides its turbulent past beneath a smooth iron crust, drifting through the galaxy as just another cold and silent remnant. This structure of retirement ensures that the most terrifying objects in the universe eventually become its most peaceful inhabitants. They join the billions of other dead stars in the cosmic graveyard, their former glory as magnetars now nothing more than a fading memory in the light they broadcast long ago. If we were to encounter one of these retired giants today, we would have no way of knowing the magnetic tyranny it once exerted over the void. The scars of the starquakes are smoothed over by gravity, leaving behind a perfect sphere that betrays none of its former violence. They remain as silent, heavy titans, their stories buried forever beneath the unyielding iron of their surface and the deep silence of the night. This final calm is the ultimate resting state for a star that once held the fabric of space in its invisible, crushing grip. We look upon these silent spheres and see only a cold remnant of a once active world, unaware of the magnetic storms that once defined their existence. They have entered a phase of eternal peace, no longer lashed by the energy ropes or tortured by the crustal stresses of their youth. In this quiet retirement, they finally find the stillness that the rest of the galaxy has always known. The stillness that the rest of the galaxy has always known is occasionally interrupted by a sudden, jarring violation of cosmic regularity known as a pulsar glitch. While these dead stars are usually the most precise and unwavering timekeepers in existence, they sometimes experience a momentary and inexplicable surge in their rotational speed that defies their standard decay. For reasons that long baffled early observers, the steady ticking of the cosmic clock abruptly quickens, as if a perfectly wound spring has suddenly released a burst of pent-up tension deep within its gears. This event happens in a fraction of a second, yet it represents a massive physical shift in an object that contains the entire mass of a sun within the diameter of a city. It is a rare moment of genuine unpredictability in a system otherwise defined by rigid mathematical law and the slow, inevitable winding down of ancient energy. We perceive this skip in the record as a sudden jump in frequency, a heartbeat that unexpectedly skips a beat, only to return faster and more energetic than it was a moment before. The sheer mechanical violence of such an event is almost impossible to grasp, as trillions of tons of matter suddenly lurch forward in their rotation. It is as if a massive spinning flywheel has been given an instantaneous and invisible push by some hidden internal hand. This sudden acceleration is the signature of the glitch, a brief flash of chaos that punctuates the eternal, rhythmic silence of the spinning remnant. Deep within the hypercompressed interior, a frictionless superfluid core plays a secret, silent game of momentum with the solid outer shell. While the iron crust of the star is constantly being slowed down by the drag of its magnetic beams, the liquid interior continues to spin with its original, undiminished ferocity. Because the superfluid possesses no viscosity, it does not experience the same friction that would normally sync its movement with the outer layers of the star. A massive reservoir of rotational energy builds up within the core, separated from the surface by an increasingly unstable physical boundary of superfluid vortices. Eventually, the discrepancy between the slow crust and the fast core becomes too great for the star to contain. The interior essentially slips, allowing the pent-up motion of the core to suddenly leak into the rigid exterior. In a sudden, violent transfer of motion, the core catches the crust, dumping its excess momentum into the solid shell and causing the observable speed-up we detect. This internal decoupling is the hidden engine of the glitch, a transfer of power that occurs in the deepest, most unreachable depths of the stellar remnant. It is a moment where the liquid heart of the star takes control, forcing the surface to match its frantic, ancient pace. This structure of internal energy transfer creates a cataclysmic event known as an internal starquake, which jolts the entire mass of the star with terrifying force. As the core and crust suddenly recouple their rotations, the resulting mechanical shockwaves ripple through the neutronium lattice at incredible speeds. It is a physical reorganization of the densest matter in the universe, occurring with a violence that would shatter any lesser celestial body. The starquake effectively resets the relationship between the various layers of the remnant, forcing them to find a new, albeit temporary, equilibrium. This sudden jolt is the ultimate release of internal pressure, a snap that restores mechanical order at the cost of a momentary explosive disruption. Every atom in the star's iron crust is subjected to a violent acceleration, a jarring movement that echoes through the local fabric of space-time. Imagine the sound of a city-sized bell being struck by a hammer made of pure gravity, creating a resonance that vibrates through the very core of the star. This is the starquake, a silent but devastating movement that reshapes the internal architecture of the pulsar in the blink of an eye. It is the physical manifestation of the glitch, the moment the star's internal tension finally overcomes its external rigidity. Surprisingly, the return to a state of perfect regularity is not instantaneous, as the star takes weeks or even months to slowly settle back into its previous steady rhythm. Following the initial jolt of the glitch, the internal fluids in the solid crust must undergo a long period of relaxation and synchronization. Astronomers watch as the pulse rate slowly decays back toward its expected timing, a process that reveals the complex interplay of forces deep within the star. Notice the gentle, rhythmic weight of your own body as it rests in complete stillness, unmoving and secure in the quiet air. While you remain at peace, the distant pulsar is engaged in a massive slow-motion recovery, gradually calming the internal turbulence triggered by its sudden snap. This relaxation period is a time of cosmic healing, where the various layers of the star find their way back to a unified rhythmic dance. The time it takes to settle provides vital clues about the viscosity and temperature of the matter trapped inside the core. It is a slow-motion echo of the initial violence, a long tale of recovery that eventually fades into the background noise of the galaxy. Only when this process is complete can the pulsar truly be said to have returned to its status as a perfect, unwavering clock. If we were to look closer at these events, we would find that watching a glitch happen provides our only direct method for peering into the bizarre internal structure of a neutron star. Because we cannot physically penetrate the iron shell or withstand the crushing gravity, we must rely on these rotational hiccups to tell us what lies beneath. The way the star speeds up and subsequently relaxes acts as a cosmic diagnostic tool, revealing the ratio of solid crust to liquid interior. Every glitch is a data-rich report, confirming the existence of the frictionless superfluid and the rigid crystalline lattice of the exterior. It is a rare opportunity to study the behavior of matter at densities that can never be replicated on Earth, turning a momentary error in timing into a profound scientific discovery. We are essentially using the star's own internal trauma to map its anatomy, reading the story of its interior in the timing of its pulses. Without these glitches, the internal world of the pulsar would remain a purely theoretical construct, forever hidden behind the unyielding iron barrier. The sudden snap is a gift to science, a brief opening of the curtain that allows us to glimpse the most extreme states of matter in the cosmos. It is a bridge between the observable surface and the hidden, liquid mysteries of the core. The unyielding outer crust resists the gradual slowing of the star with a stubborn rigidity until it finally shatters under the immense rotational strain. Because the pulsar is slightly flattened at its poles due to its spin, any change in speed requires the solid shell to change its shape to maintain gravitational balance. However, the iron lattice is so strong that it refuses to deform gradually, instead building up catastrophic levels of stress over many years. Eventually, the crust reaches a breaking point and fractures in a spectacular display of structural failure, allowing the star to settle into a more spherical configuration. This shattering is the catalyst for the glitch, the moment the physical container of the star finally gives way to the relentless demands of its own momentum. The iron bonds snap like brittle glass, releasing the energy that has been stored for decades within the metallic lattice. This crustal failure is the surface-level trigger that allows the internal superfluid to finally transfer its momentum to the exterior. It is a moment of total structural collapse, a shattering of the perfect sphere that allows a new, more stable shape to emerge. The star is literally reborn through the destruction of its own surface, finding a new lease on its rhythmic life through the act of breaking. Imagine an ice skater spinning in the center of a frozen pond, pulling their arms in slightly to cause a sudden, microscopic burst of speed in their spin. This fundamental law of physics, the conservation of angular momentum, is the same principle that governs the behavior of a glitching pulsar. As the internal starquake forces a slight reorganization of the star's mass toward its center, the rotation must naturally quicken to compensate for the change in distribution. It is a graceful and inevitable reaction to a shift in geometry, occurring on a scale involving an entire sun's worth of material compressed into a tiny volume. This analogy helps us visualize how a tiny change in shape can lead to a massive, detectable surge in the star's rhythmic heartbeat across the void. The pulsar is merely following the same rules that govern the movements of a human dancer on Earth, albeit at a level of intensity that is difficult to imagine. The star tucks in its arms when the crust shatters, drawing its mass inward and spinning faster as a result. This sudden burst of kinetic energy is a celebration of the laws of motion, a cosmic pirouette performed in the absolute dark. It is the most dramatic display of physics in action, where the invisible force of momentum dictates the fate of a massive spinning giant. These events release immense bursts of energy, sending invisible ripples through the star's magnetic field and momentarily altering the intensity of its emission beam. As the crust fractures and the star jolts, the magnetic field lines anchored in the surface are violently shaken, creating a turbulence that disrupts the steady flow of particles. Astronomers detect these ripples as a sudden flicker or change in the shape of the pulses hitting our telescopes, a secondary signal of the internal chaos. Notice the stillness of your own hands and the quiet, steady nature of your environment as you contemplate these distant magnetic storms. The energy released is so vast that it can be detected across thousands of light years, a signature of a world experiencing a sudden structural rebirth. The very beam of light that defines the pulsar is twisted and warped by the shock waves of the starquake, creating a visual record of the snap. These ripples act as a cosmic broadcast, announcing the star's internal struggle to anyone listening in the radio or X-ray spectrum. The magnetic field behaves like a plucked guitar string, vibrating with the energy of the crustal fracture. It is a symphony of radiation and motion, where every pulse carries the frequency of the star's sudden reorganization. Surprisingly, the Vela pulsar has become famous in the scientific community for glitching with a rhythmic regularity that mirrors a highly predictable cosmic geyser. Approximately once every 3 years, this specific remnant experiences a massive snap, allowing researchers to set their instruments and wait for the inevitable disruption. This predictability suggests that the buildup of stress within its crust and the lag of its superfluid core follow a strictly mechanical cycle. It has become a reliable laboratory for studying the life cycle of stellar fractures, proving that even accidents in space can follow a structured and orderly path. The Vela pulsar stands as a rhythmic reminder that the universe's most violent hiccups can still be part of a grander, predictable design. We can almost hear the tension building over the years, waiting for the inevitable moment when the spring finally releases its grip. This regularity allows us to test our models of nuclear matter with a precision that would be impossible with more erratic objects. The star is a faithful partner in our quest for understanding, providing a repeatable experiment in the most extreme conditions imaginable. It is the most reliable geyser in the cosmos, erupting with energy and motion on a schedule that we have finally learned to read. Ultimately, this repeated cycle of fracturing and settling ensures that each glitch slightly reshapes the star's perfect spherical geometry, smoothing out the tiny millimeter-high mountains on its surface. As the crust shatters and reforms in the wake of the starquake, the extreme gravity uses the opportunity to pull the surface into a more uniform and balanced state of rest. Those tiny ridges of iron, which were pushed upward by years of internal tension, are flattened by the violence of the jolt and the subsequent reorganization. The result is a sphere that is even more flawlessly smooth than it was before the glitch, a cosmic object that uses its own internal trauma to achieve a state of geometric perfection. It is the final, microscopic refinement of the pulsar's form, a polishing process occurring in the heart of a catastrophic internal snap that leaves the star more silent and balanced than ever. In this way, the star's violent outbursts are actually the mechanism for its journey toward an ever-increasing physical calm. The star emerges from its period of instability as a more perfect version of itself, its surface polished by the very forces that sought to tear it apart. It is a beautiful paradox where destruction leads to greater order, and a sudden snap results in a more perfect, lasting stillness. The mountains are gone, the crust is reset, and the pulsar continues its rhythmic dance with a renewed sense of mechanical purity. Even in this state of mechanical purity and apparent stillness, the pulsar is often far from stationary, hurtling through the galactic void at velocities that defy conventional orbital mechanics. As this hyperdense sphere tears through the near vacuum of space, its powerful and relativistic winds act like a colossal cosmic snowplow. These winds, composed of high-energy particles and intense magnetic energy, slam into the thin, cold interstellar gas that populates the regions between stars. Instead of simply passing through the gas, the pulsar physically sweeps it up, compressing the diffuse material into a dense and energetic barrier. This relentless forward motion creates a dynamic interaction where the star's internal energy meets the external environment of the galaxy. The result is a violent clearing of the path ahead, as the pulsar carves a tunnel through the dust and gas of the deep dark. This structure of kinetic interaction transforms the silent remnant into an active sculptor of the interstellar medium. The gas is not merely displaced, it is energized and pushed aside, creating a localized pocket of high-pressure plasma that marks the star's trajectory. It is a constant, sweeping movement that ensures the pulsar never truly experiences a moment of rest as it navigates the vast celestial ocean. This relentless ploughing through the galactic medium generates a massive glowing bow shock that stands as a luminous herald of the star's approach. Much like the wave of water that piles up in front of a ship's prow, this shockwave is a region of intense compression where the pulsar wind meets the resistance of the interstellar gas. The temperature in this shock front spikes as kinetic energy is converted into heat, causing the gas to glow with an ethereal and invisible light. While these structures are often invisible to the naked eye, modern infrared telescopes can perceive them in spectacular detail, revealing the intricate geometry of the encounter. The bow shock often appears as a sharp, brilliant arc or a complex cone, trailing backward from the direction of the star's motion. It is a visual record of a high-speed collision occurring across vast distances of space, a glowing signature etched into the infrared spectrum. The geometry of these shocks provides astronomers with a wealth of information regarding the star's velocity and the density of the gas it is currently penetrating. By studying the curve and intensity of the glow, we can calculate exactly how much force the pulsar is exerting on its surroundings. It is a stunning display of kinetic power, a radiant shield that protects the star even as it disrupts the tranquility of the deep dark. One of the most breathtaking examples of this kinetic artistry is found in the Guitar Nebula, created by a pulsar tearing through space at immense speeds. As the star screams through the interstellar medium, its bow shock has been shaped by the varying density of the gas into a form that strikingly resembles the body of a classical guitar. The neck and headstock of the structure are formed by the star's earlier path, while the current body marks a region where it hit a denser patch of material. This structure is not a static cloud, but a churning and evolving wake that stretches for enormous distances behind the speeding star. Every curve and bulge in the nebula represents a change in the environment the pulsar has traversed over eons. It is a chronological map of a journey through the galaxy, a celestial fossil of a high-speed transit that remains visible long after the star has moved on. If we were to look closer, we would see that the strings of this cosmic instrument are actually streams of high-energy particles being shed by the star's intense magnetic field. The entire nebula is a testament to the sheer scale of the disruption, caused by a city-sized object moving at such extreme velocities. It stands as a masterpiece of accidental design, a beautiful consequence of a dead star's frantic flight across the deep dark. These high-speed stars are not born with their velocity by accident, but are often violently ejected from their birthplaces by asymmetrical supernova explosions. When the progenitor star collapses, the explosion is rarely a perfectly uniform event. Instead, more energy or mass may be blasted out in a specific direction. This imbalance creates a powerful recoil, acting like a massive and powerful rocket engine that kicks the newly formed neutron star in the opposite direction. The force of this natal kick is so immense that it can propel the pulsar out of its original solar system at speeds far exceeding the typical orbital velocity of other stars. They become the runaways of the galaxy, stripped of their former neighbours and cast into the void on a trajectory that leads away from their ancestral homes. This ejection is a final and parting gift from the violent death of the massive star that preceded them. Surprisingly, the universe uses this kinetic energy to populate the far reaches of the galaxy with these rhythmic beacons. Notice the weight of your own body resting against your chair or bed, tethered by a gravity that feels steady and unchanging, In contrast, these stars are in a state of permanent and high-velocity exile, driven by the echoes of an explosion that occurred in the distant past. As the pulsar navigates its path of exile, the energy it injects into the surrounding space plays a vital role in heating the interstellar medium. The high-energy particles and magnetic turbulence generated by the star's motion prevent the surrounding gas from freezing into a completely inert state. This localized heating keeps the diffuse clouds of hydrogen and dust in a state of agitation, maintaining the dynamic balance of the galactic environment. The pulsar effectively acts as a cosmic heater, transferring its own rotational and kinetic energy into the cold pockets of the deep dark. This energy injection can influence the formation of future stars by preventing gas clouds from collapsing prematurely, or by triggering waves of compression that start the process of starbirth. It is a profound irony where a dead star, having finished its own life cycle, provides the thermal energy necessary to stir the precursors of new life. If we were to look closer at the region surrounding a fast-moving pulsar, we would see a wake of warm gas stretching for light years in its trail. This warmth is a lingering legacy of the star's passage, a thermal footprint that persists long after the beacon has moved into the next sector of space. The deep dark is thus not merely a cold void, but a place occasionally touched by the radiant heat of these speeding remnants. Extending far behind these runaway stars are long trails of high-energy particles that can stretch for multiple light-years across the galactic plane. These trails are composed of the electrons and positrons that have been accelerated by the star's magnetic field and left behind in its wake. They form glowing and ethereal streamers that act as long-lasting markers of the pulsar's historical path through the galaxy. The particles in these trails continue to glow with energy for centuries, creating a luminous bridge between the star's current position and its distant origin point. These structures are often narrow and tightly collimated, resembling the contrails left by high-altitude aircraft in our own atmosphere. They provide a visual record of the star's interaction with the magnetic fields of the galaxy itself, showing how the pulsar's aura is stripped away by its own motion. This structure of trailing energy reveals the immense quantity of matter the pulsar sheds as it spins and travels through the void. The trails are not just empty paths, but are filled with a simmering plasma that interacts with the interstellar magnetic field in complex ways. They are the ribbons of the deep, dark, long and winding trails of light that connect the runaway star to its violent past. Picture a speedboat cutting across the glass-like surface of a still lake, leaving a wide and churning wake of white foam and bubbles in its path. This terrestrial image provides a surprisingly accurate mental model for the behavior of a pulsar as it interacts with the interstellar medium. The foam in the cosmic wake is the glowing plasma and compressed gas created by the star's relentless forward pressure and intense radiation. The wake churns with turbulence, creating eddies and waves in the gas that can persist for eons after the star has passed. Just as the boat's wake eventually spreads out and dissipates, the pulsar's trail slowly merges with the surrounding medium, enriching it with high-energy particles and heavy elements. It is a process of constant disturbance and eventual integration, where the star's kinetic energy is slowly absorbed by the galaxy at large. Softly validate the stillness of your own environment, feeling the quiet air around you as you contemplate this high-speed churning in the far reaches of space. The lake of the galaxy is disturbed by these invisible speedboats, creating a network of wakes that crisscross the spiral arms in a chaotic yet beautiful patterns. It is a dynamic and ever-changing landscape of motion, where the dead stars are the most active participants in the cosmic environment. The particles accelerated by these powerful bow shocks do not stay localized, but eventually escape the star's immediate vicinity to contribute to the constant rain of cosmic rays striking the Earth's atmosphere. These relativistic electrons and atomic nuclei are flung into the depths of space, travelling for countless eons before some of them collide with our planet. They represent a direct and physical connection between the high-speed transit of a pulsar and the environment of our own home. When these cosmic rays hit the upper atmosphere, They create showers of secondary particles that can be detected by specialized instruments on the ground. Every time one of these particles passes through your body, it is a tiny and high-energy messenger from a distant bow shock somewhere in the galaxy. We are constantly being bombarded by the fragments of a pulsar's wake, a silent and invisible rain from the deep dark. Studying the composition of these rays allows scientists to understand the extreme acceleration processes occurring at the fronts of these glowing shocks. It is a way of sampling the environment of a runaway star without ever leaving the safety of our own atmosphere. We are the unintended recipients of the pulsar's kinetic waste, a global laboratory for the physics of the most distant wakes. Studying these glowing trails and the shapes of the bow shocks helps astronomers map the density and magnetic field strength of the seemingly empty space between stars. The way a pulsar's wake twists or bulges reveals the hidden topography of the interstellar medium, showing us where the gas is thick and where it is thin. It is like watching the smoke from a fire reveal the invisible currents of air in a large room, giving shape to the void. The orientation of the trails also provides vital clues about the direction and intensity of the galactic magnetic field in that specific sector of space. As the high-energy particles follow the field lines, the trails can be seen to curve or spiral, tracing out the invisible architecture of our galaxy. What was once considered a featureless and empty void is thus revealed to be a complex and structured environment filled with currents and barriers. Notice the quiet rhythm of your own pulse as you think about how these distant pulses help us map the entire galaxy. Every runaway star is a surveyor, measuring the properties of the vacuum as it hurtles toward the edge of the galactic plane. We are learning to read the language of the wakes, using the star's frantic flight to understand the home they are so desperately trying to leave behind. Eventually, many of these runaway stars will achieve speeds so high that they will escape the gravitational grip of our galaxy entirely, destined to wander the intergalactic void alone. These stars have reached the escape velocity of the galaxy, a threshold that ensures they will never return to the arms of their birthplace. They are the final emigrants of our stellar system, leaving behind the staggering number of stars they once lived among to seek the ultimate isolation. Once they enter the intergalactic void, they will continue to pulse in total isolation, with no gas or dust to create bow shocks or glowing wakes. They will become the loneliest objects in the universe, silent lighthouses in the vast nothingness between the great galaxies. The rhythmic ticking of their cores will be the only thing that remains, a persistent heartbeat in a place where time and space seem to have no meaning. This final journey into the absolute dark marks the end of their interaction with the galaxy that forged them. They are the plowshares of the deep dark that have finally finished their work, heading out into an eternal and lonely frontier. Their signals will eventually fade as they move further away, leaving only the memory of their high-speed passage etched into the infrared maps of the galaxy. While the memories of their high-speed passage fade into the infrared maps of the galaxy, the legacy of pulsars extends into the very geometry of the universe itself. Binary pulsars, where two neutron stars orbit one another in a tight gravitational embrace, provide the most perfect natural laboratories for testing Albert Einstein's theory of general relativity. These systems represent environments so extreme that the subtle warping of space and time becomes a measurable, macroscopic reality rather than a theoretical abstraction. In the quiet corridors where I conduct my research, we often marvel at how these binary systems serve as a gold standard for our understanding of the cosmos. They allow us to probe the limits of gravity in ways that would be impossible within the gentle confines of our own solar system, or even our most powerful particle accelerators. This structure of high-mass interaction creates a stage where the most elegant and complex equations of modern physics are played out with uncompromising, crystalline precision. We are no longer just theorizing about the curvature of the universe. We are observing it in the rhythmic pulses of stars that are locked in a relentless gravitational grip. It is a profound realization that a pair of city-sized objects, thousands of light years away, can hold the key to the fundamental laws that govern every atom in our bodies. This scientific elegance is a testament to the order that underlies the apparent chaos of the stellar graveyard. As these two massive stellar remnants spiral around their common centre of mass, they do more than just orbit. They physically stir the fabric of space-time. This violent churn generates invisible ripples known as gravitational waves that radiate outward at the speed of light, carrying away energy and momentum from the binary system. It is a silent, rhythmic agitation of the cosmic background, a testament to the fact that even the vacuum of space can be moved by the dance of titans. These waves are not mere echoes of light, but are actual vibrations of space itself, stretching and squeezing the universe as they pass through it. This structure of emission was predicted over a century ago, but it is through the careful monitoring of binary pulsars that we have found our most compelling evidence. The energy lost to these invisible waves is substantial, acting as a slow-motion drain on the orbital vitality of the stars. Deep within the timing data of our receivers, we find the signature of a universe that is not a static backdrop, but a dynamic, reactive medium that responds to the movement of mass. This cosmic agitation serves as a reminder that everything in the universe is connected by a web of gravitational influence that transcends the reach of light. We are effectively listening to the vibration of the vacuum, a soundless hum produced by the most intense machines in the galaxy. Surprisingly, the loss of energy to these invisible ripples has a tangible and permanent effect on the architecture of the binary system. Einstein predicted that as energy is radiated away, the two stars must inevitably draw closer together, causing their orbits to shrink by a few millimeters every single year. This microscopic shift in distance is detected through the slight, cumulative changes in the pulsar's orbital period over decades of meticulous observation. Notice how your own breathing is steady and localized, while these massive spheres are caught in a slow, multi-million-year spiral toward an eventual and cataclysmic union. This structure of decay is so perfectly aligned with the predictions of general relativity that it serves as one of the most rigorous tests of the theory ever conducted. We're effectively watching a planetary-scale clock slowly wind down, its rhythm governed by the emission of waves we cannot see. The precision required to measure such a tiny change across the vastness of space is a testament to the dedication of the global scientific community. It is a quiet, inevitable progression, a descent into the dark that will one day culminate in a merger so powerful it will be felt across the entire observable universe. This slow-motion collision is the ultimate proof that the energy of a star is never truly lost, but transformed into the geometry of space. This structure of warped space extends beyond the orbital dance, as the intense gravity of a foreground pulsar can act as a natural lens for the rest of the universe. When such a dense object passes directly in front of a distant galaxy, its gravity bends and magnifies the light from that background source, creating a distorted but brilliant projection. It is a cosmic optical illusion that allows astronomers to peer deeper into the dark, using the heavy star as a magnifying glass forged from the curvature of space itself. This phenomenon, known as gravitational lensing, effectively turns a dead star into a scientific instrument of incredible power and precision. The light from a galaxy billions of light-years away is refocused and amplified by the pulsar's gravity, revealing details that would otherwise be lost to the void. By analysing these distorted images, we can map the distribution of dark matter and the expansion of the universe itself. If we were to look closer at these distorted images, we would see the light forming perfect arcs, or Einstein rings around the central mass. It is a beautiful manifestation of the idea that mass and light are inextricably linked by the geometry of space. This lensing effect provides a unique window into the distant past, allowing us to see the early stages of the universe through the lens of its most compact remnants. If we were to look closer at the timing of the pulses, we would observe a subtle and beautiful phenomenon known as the Shapiro delay. As the beam of radiation from the pulsar travels past its massive companion on its way toward Earth, it must navigate a region of space where gravity is significantly more intense. This intense pull physically slows the signal's arrival time, causing it to arrive a fraction of a millisecond later than it would have in flat, unwarped space. This delay occurs because the light is not merely travelling through space, but through a space that has been stretched and curved by the presence of a heavy mass. The photons must take a slightly longer path through the gravitational valley, created by the companion star, a detour dictated by the curvature of the field. This effect is a direct confirmation that time and space are not independent constants, but are woven together into a single four-dimensional fabric. Every time the pulsar passes behind its partner, its signal carries the imprint of this geometric delay, a rhythmic signature of the companion's invisible weight. It is a staggering thought that we can measure the shape of space by simply timing the arrival of a radio pulse from across the galaxy. We are using the universe's most precise clock to map the depth of its deepest valleys. This slight, predictable delay is not merely a curiosity, but a precision tool that allows scientists to calculate the exact mass of both stars with unprecedented accuracy. By measuring how much the signal is slowed during its passage through the companion's gravity well, we can determine the weight of these invisible titans down to a fraction of a percent. This structure of calculation allows us to distinguish between different theories of how matter behaves under the most extreme pressures imaginable. Softly validate the quiet stillness of your environment, feeling the gravity of Earth as a gentle, constant presence, while these cosmic clocks measure the weight of the dark. We can tell exactly how much mass is required to force the core of a star into its exotic, hyper-dense state of neutronium. The Shapiro delay provides the cosmic scale upon which we weigh the remnants of supernovae, giving us a concrete number for objects that are otherwise abstract and distant. It is a triumph of mathematical physics, where the subtle timing of light reveals the true nature of the heaviest objects in the galaxy. This level of precision is virtually impossible for any other stellar system, turning a delay in timing into a master key for understanding the internal structure of neutron stars. We are weighing the heavier souls of the galaxy using nothing but the tick of a clock and the bend of a light ray. Deep within the physics of these objects, space behaves like a deep, invisible funnel, where light itself has to climb out of a steep and punishing gravitational well. Every photon emitted by the pulsar loses energy as it fights against the immense downward pull, a struggle that manifests as a subtle stretching of the light's wavelength. This loss of energy is a direct result of the star's density, where the gravitational field is so strong that it physically drains the vitality of the light itself. The deeper the well, the harder the climb, and the slower the clocks at the bottom appear to tick from our distant vantage point. It is a place where the passage of time is a variable dictated by the proximity of mass, a twisting of reality that occurs at the very edge of the star. This structure of gravitational time dilation means that if you were to stand on the surface of the pulsar, time would pass significantly slower for you than for someone watching from Earth. A second on the star's surface is longer than a second in the empty void, a direct consequence of the star's massive gravitational field. This effect, though subtle from our perspective, is a fundamental part of the star's existence, defining the rhythm of its pulses and the frequency of its light. We're observing the universe through a lens of shifting time, where the heaviness of the dark star slows the very clock of the cosmos. The rapid rotation of the star adds another layer of complexity to this warped landscape, as it physically drags the surrounding fabric of space-time along with it. This mind-bending phenomenon, called frame dragging, ensures that any object or light ray passing near the spinning star is caught in a subtle, rotational swirl. It is as if the star is a heavy ball spinning in a thick liquid, forcing the space around it to mimic its frantic mechanical movement. This structure of a space-time whirlpool was another profound prediction of general relativity that has found its confirmation in the study of binary systems. The very coordinates of space are pulled along by the star's rotation, a process that slightly shifts the orientation of the pulsar's orbit over time. This effect, though incredibly small, is detectable through the meticulous long-term monitoring of the pulsar's signal timing and orbital precession. It reveals a universe where mass does not just sit in space, but actively manipulates and twists the medium it inhabits like a sculptor working with clay. If we were to look closer, we would see that the star's rotation is not just an internal characteristic, but an external force that reshapes the local geometry of the universe. The star and space are locked in a spinning embrace that defies our basic understanding of stillness. Surprisingly, observing these extreme systems and their relativistic effects has led to multiple Nobel Prizes for astronomers who confirmed the strangest and most beautiful predictions of modern physics. These scientists used the precise ticking of pulsars to prove that gravity travels at the speed of light and that space-time is a dynamic, reactive substance. Their work turned the theoretical scribblings of Einstein into a confirmed physical reality, using the deep dark as a cosmic laboratory for the most rigorous testing ever attempted. This structure of discovery has reshaped our understanding of the universe, proving that the most exotic ideas often find their home in the most extreme remnants of stellar death. The discovery of the first binary pulsar was a watershed moment in astrophysics, providing the first indirect evidence for the existence of gravitational waves decades before they were directly detected. It was a victory for patient observation and the belief that the universe's most profound secrets are written in the timing of its most distant lights. Notice how the ground beneath you feels solid and unchanging, while the very foundation of modern science was built on the subtle wobbles of these faraway stars. These accolades are a testament to the power of human curiosity and our ability to decode the language of the stars from across the infinite night. We have turned a rhythmic flicker into a profound understanding of the laws that hold the cosmos together. Ultimately, the precision of these signals is so perfect that they rival or even exceed the accuracy of the best atomic clocks ever constructed by human engineering. While our terrestrial clocks rely on the vibrations of atoms, these cosmic timekeepers are governed by the rotation of an entire sun's mass, making them immune to the trivial perturbations of our world. They offer an unwavering and eternal baseline for the passage of time, ticking away with a consistency that will endure for billions of years. This structure of stability allows us to use pulsars to detect even the most microscopic fluctuations in the galactic environment, such as the passage of a low-frequency gravitational wave. We are effectively using the entire galaxy as a single, massive clock, synchronized by the rhythmic beating of these dead stars. Every pulse is a perfect tick of a cosmic metronome, a signal that has been refined by the extreme physics of a neutron star's interior. As you sink into the final depths of your relaxation, consider that somewhere in the deep dark, a clock is ticking with a precision that will outlast everything we have ever built. It is the ultimate standard of time, a heartbeat from the stars that defines the very meaning of a second in the infinite ocean of space. We are passengers on a journey through time, guided by the steady and eternal rhythm of the lighthouses in the void. This eternal rhythm of the lighthouses in the void serves as the ultimate standard of time, but it also provides a profound and unchanging guide for navigating the infinite ocean of space. Every one of these rotating beacons possesses a rotational frequency so specific and unwavering that it acts as a unique fingerprint in the cosmic dark. Because no two pulsars spin at exactly the same rate, with differences calculated down to dozens of decimal places, they effectively function as a network of natural GPS satellites distributed throughout the spiral arms of our galaxy. By precisely measuring the timing and direction of several of these signals simultaneously, an explorer can triangulate their exact position in three-dimensional space with remarkable accuracy, whether they are near the Sun or the galactic core. This structure provides a permanent self-updating reference frame that does not rely on human-made technology, vulnerable ground stations, or the proximity of a nearby planet. It is a navigational grid forged from the heavy remnants of dead stars, a map that exists entirely independently of the observers who use it. This mathematical uniqueness allows the pulsar to act as an absolute coordinate in a universe where everything else is in a state of constant relative motion. As you lie here, feel the steady, slow beating of your own heart and consider how your own presence is mirrored by these cosmic beacons. The galaxy is no longer a trackless wilderness, but a structured domain of time and space, where every spinning remnant points the way for those who know how to listen. Surprisingly, humanity has already utilised this celestial grid to broadcast our home's location to any potential travellers in the interstellar void. The famous Golden Record, carried by the Voyager spacecraft and its predecessor on the Pioneer probes, contains a complex diagram etched into a metal plaque that uses 14 distinct pulsars as cosmic signposts. By indicating the direction and specific, unique timing of these 14 beacons relative to our Sun, the map provides a timeless set of coordinates for finding the Earth. It is a golden message of hope and curiosity, a geometric handshake offered to the infinite night that assumes any intelligent observer will recognize the universal language of these rotating clocks. This structure ensures that even if our planet were to vanish, or its civilizations were to fade, the record of its existence remains tethered to the most stable and enduring objects in the universe. We have essentially defined our place in the cosmos not by our borders, but by our proximity to the lighthouse keepers of the deep dark. The plaque serves as a bridge between the temporary existence of a biological species and the eternal endurance of the stellar graveyard. It is a humbling thought that our global information is simplified into a series of lines and frequencies, recorded on a plate of gold hurtling through the vacuum. We are a part of the Pulsar story now, a tiny coordinate in a grand, rotating ledger of the Milky Way. If we were to look closer at the future of human exploration, we see the potential for spacecraft to navigate autonomously across the solar system using specialized X-ray telescopes. Unlike radio waves, which require massive, unwieldy dish antennas to capture, the sharp X-ray emissions from millisecond pulsars can be detected by much smaller and more efficient sensors suitable for deep space probes. This technology, recently demonstrated by orbiting experiments, allows a ship to determine its velocity and position in real time by analysing the arrival times of high-energy photons from a network of known pulsars. It removes the need for constant delayed communication with Earth-based tracking stations, granting our robotic emissaries a newfound independence as they venture into the outer reaches. This autonomous capability is essential for long-duration journeys beyond the reach of our home planet's immediate influence, where a signal might take hours to return. By listening to the X-ray heartbeat of the stars, our machines can find their way through the vacuum without ever needing to look back at the world that created them. It is a transition from terrestrial dependence to celestial self-sufficiency, using the raw energy of the stars to carve a path through the dark. Notice the stillness of your own environment, feeling the safety of a world that is beginning to learn the language of the cosmos. Our future among the stars depends on these rhythmic guides, the heavy, silent titans that have been marking the way since long before we arrived. This navigation method is not a fleeting solution, as it remains mathematically accurate for millions of years, long after our artificial satellites have decayed and fallen from orbit. While human-made GPS systems require constant maintenance, relativistic corrections, and frequent updates from ground control to remain functional, the Pulsar network is self-sustaining and incredibly durable. The slow, predictable spin-down of these stars is understood so thoroughly that it can be modelled with such precision that the passage of eons does not diminish their utility as beacons. Notice the deep, effortless flow of your breathing as you contemplate a map that remains valid for millions of years in the silence of space. It is a system built on the bedrock of stellar physics, a navigational legacy that outlasts civilizations, the shifting of continents, and the very memory of the societies that first mapped them. These stars will continue to beat out their time long after the last terrestrial clock has stopped, providing a permanent lighthouse service for any traveller who might one day wander through the galactic arms. They are the ultimate insurance policy for our species, a way home that survives the death of the world that conceived it. We are investing our knowledge in the most stable assets of the universe, ensuring that the light of discovery never truly goes out. In the deep future, these stars will be the only things left that remember where we once stood. Deep within the world of modern astrophysics, researchers are currently employing massive networks known as pulsar timing arrays to search for the ultra-low frequency gravitational waves produced by merging supermassive black holes. These waves are not produced by the sudden, violent collision of stellar mass remnants, but by the slow, grinding orbits of giants at the centres of distant, merging galaxies. Because these ripples have wavelengths that stretch for trillions of miles, they're far too large to be detected by ground-based laser interferometers, which are limited by the size of our planet. Instead, we use the stable pulses from dozens of millisecond pulsars across the sky as the arms of a detector that spans the entire galaxy. This structure allows us to listen to the deep, resonant growl of the universe's heaviest inhabitants as they slowly dance toward one another across millions of light years. By treating the space between these stars as a sensitive medium, we are finally opening a new window into the history of how galaxies and their central black holes grow and evolve. It is a form of cosmic eavesdropping, where the rhythmic heartbeat of one star reveals the silent movement of another giant. We are no longer limited by what we can see, but by what we can feel through the subtle timing of the stars. The universe is speaking in a low-frequency hum, and the pulsars are the only microphones sensitive enough to capture the sound. As these gargantuan waves wash over the Earth, they slightly alter the physical distance between our telescopes and the various pulsars in the timing array, stretching and squeezing the vacuum in a predictable pattern. This microscopic fluctuation in the fabric of space-time manifests as a detectable shift in the arrival times of the pulses, creating a subtle, correlated pattern of delays and advances across the sky. By analysing these timing changes over decades, scientists can identify the characteristic correlations that prove the origin of these disruptions is indeed gravitational waves. It is a delicate and painstaking process of data subtraction, requiring the world's largest radio telescopes to work in unison to extract the faint signature of the waving vacuum. This structure of detection confirms that our planet is constantly bobbing like a cork in a sea of gravitational ripples that span the entire Milky Way, created by events occurring at the edge of the observable universe. It is a profound realization that the rhythm of a distant star is the only thing sensitive enough to reveal the subtle warping of our own local space. Notice how the ground beneath you feels solid and unchanging, while the very space you inhabit is constantly rippling with the energy of distant collisions. We are part of a cosmic ocean, connected by threads of gravity that pulses allow us to see. Every tick of the stellar clock is a measurement of the universe's invisible breathing, a steady beat in a surging rhythmic sea. Surprisingly, we have learned to use the entire Milky Way galaxy as a single, massive scientific instrument to listen to the ancient vibrations of the universe. By treating every pulsar as a remote, hyper-accurate sensor in a vast coordinated web, we have essentially transformed the space between the stars into the largest detector ever conceived by the human mind. This galactic-scale instrument allows us to observe events that occur on timescales and distances that dwarf any terrestrial experiment, reaching back to the dawn of cosmic structure. We are no longer limited by the physical size of our own world, as we have harnessed the inherent precision of the heavens to serve our scientific curiosity. Notice the weight of your body as you relax, feeling your connection to a world that has turned the stars into a global laboratory. This realization represents a peak of human ingenuity, where the natural rhythmic order of the dead stars becomes a tool for our own collective enlightenment and survival. We are the architects of a telescope made of light and gravity, listening to the secrets of the deep dark. It is a transition from being observers of the universe to being participants in its grand mechanical design. The galaxy is no longer just a place we live. It is a tool we use to understand the fundamental nature of existence. The study of these stars bridges the gap between the microscopic realm of quantum mechanics and the macrophysics of galactic structures in a way that few other objects can. Inside the hypercompressed core of a pulsar, matter exists in a state governed by the strange laws of subatomic particles, where neutrons are packed together in a liquid-like superfluid. Yet, the outward behaviour of this quantum core dictates the timing of radio signals that traverse thousands of light-years to reach our detectors. This structure of interconnected scales allows physicists to test the most extreme theories of dense nuclear matter, which has direct consequences for our understanding of how gravity and matter interact. By understanding the smallest fragments and forces inside a neutron star, we gain insight into the largest and most complex gravitational systems in the entire cosmos. It is a stunning paradox where the fate of a galaxy is written in the behaviour of particles too small to be seen by any microscope, a bridge between the infinitesimal and the infinite. We are using the most compact objects in the universe to explain the structure of the universe itself. Sink deeper into the quiet heaviness of your relaxed muscles, realizing that the same laws governing the stars are governing the very atoms of your body. The pulsar is the ultimate translator, turning the hidden language of quantum physics into a rhythmic signal we can all understand. Our ongoing mapping of these objects is slowly revealing the hidden architecture of the magnetic fields that permeate every corner of our galaxy, acting as a cosmic circulatory system. As the radio signals from pulsars travel through the interstellar medium, they undergo a phenomenon where the light's polarization is twisted by the magnetic fields it encounters. By analysing these subtle rotations across thousands of different pulsar signals, astronomers are constructing a three-dimensional map of the magnetic weather that governs the movement of gas in the Milky Way. This structure of invisible lines acts as the connective tissue of the galaxy, influencing where new stars are born and how cosmic rays are channeled through the spiral arms. If we were to look closer, we would see a complex tapestry of loops, arcs, and filaments that have been invisible to us for most of human history. We are finally seeing the magnetic skeleton of our home, revealed entirely by the light of the ticking lighthouses that illuminate the deep dark. It is a mapping of the invisible, a way of seeing the forces that hold the galaxy together through the timing of its most distant lights. Every pulsar discovered adds another thread to this tapestry, revealing a universe that is far more structured and organised than we ever dared to imagine. We are no longer blind to the magnetic currents of our home. We are learning to sail them using the stars as our guides. These rhythmic beacons stand as enduring testaments to the violent yet creative forces that shape the cosmos, offering a steady light in the overwhelming dark for any who know how to listen. They are the survivors of total destruction, the transformed remains of stars that once lived briefly and died in the most spectacular explosions the universe can produce. This structure of persistence ensures that the energy of the past is not merely lost to entropy, but is instead recycled into a form that provides order, timing, and guidance to the present. The pulsar is a symbol of absolute resilience, a clock that refuses to stop even in the face of gravitational collapse and the freezing vacuum of the void. As we gaze upon their signals, we find a sense of profound permanence in a universe that is otherwise defined by constant change and the eventual cooling of the stars. They are the steady heartbeats of the galaxy, reminders that even in the aftermath of a catastrophe, a new and beautiful order can emerge from the wreckage. Their presence ensures that the light of discovery never truly fades into the background noise of the infinite night. We are the inheritors of this light, the students of a rhythm that spans the eons and connects us to the very beginning of time. In the silence of the void, the pulsars continue to beat, steady and true, a testament to the enduring power of the cosmos. In the pulse of these dead stars, we discover a profound harmony where the ultimate violence of a supernova is refined into a perfect eternal rhythm, revealing that the universe does not merely end in darkness, but transforms its own wreckage into the very clocks and compasses that allow us to find our way home. This grand synthesis of destruction and order shows us that every ending is merely the forge for a more precise and enduring beginning. We are not lost in the deep dark, because the stars have left us a map made of time and light, a legacy of resilience that echoes across the galactic arms. The journey from the explosion of a giant to the rhythmic ticking of a city-sized core is the story of the universe itself, a process of compression that yields the most perfect instruments in existence. We have learned to read the heartbeat of the cosmos, to navigate the magnetic currents of our home, and to listen to the vibrations of space-time itself through these iron-crusted sentinels. They are the anchors of our reality, the steady beats in an infinite and surging ocean of shadow. As you drift into the final stillness of your rest, remember that the pulses are still there, spinning in the dark, keeping the time for a universe that never truly sleeps. We are home, guided by the light of the lighthouses in the void, forever connected to the eternal rhythm of the stars. In the pulse of these dead stars we find a profound harmony, where the ultimate violence of a supernova is refined into a perfect, eternal rhythm, revealing that the universe does not merely end in darkness, but transforms its own wreckage into the very clocks and compasses that allow us to find our way home. This grand synthesis of destruction and order shows us that every ending is merely the forge for a more precise and enduring beginning. We are not lost in the deep dark because the stars have left us a map made of time and light, a legacy of resilience that echoes across the galactic arms. Surprisingly, the body responds to this cosmic order by seeking its own state of absolute equilibrium in the stillness of the hushed hours. If we were to look closer at your feet, we would see them releasing the tension of the day, sinking into the mattress as if a gentle gravity were anchoring them. Every toe softens, shedding the weight of movement and finding a heavy, comfortable rest against the cotton sheets. Deep within your calves and knees, the muscles begin to uncoil like a perfectly wound spring finally finding its release. This quiet room becomes a sanctuary where the physical effort of being is no longer required. Your thighs and hips grow heavy, becoming part of the landscape of the bed, perfectly supported and perfectly still as the slow rotation of the world carries you onward. This quiet room is filled only with the soft, muffled sounds of a house at rest. Your lower back sinks into the mattress, finding a deep and supportive comfort that holds you without effort. The fingers on both hands curl naturally, releasing their grip on the day as the palms grow warm and still. A gentle wave of relaxation flows upward into the center of your chest. The breath moves in and out with a slow, effortless cadence that requires no thought or direction. Each exhale carries away a little more tension, leaving the ribs and the heart to settle into a peaceful, rhythmic slow. If we were to look closer at the face, we would find the jaw relaxing into a slight natural gap. The tongue rests quietly, and the tiny muscles around the eyes smooth out until they are completely at peace. A soothing coolness spreads across the forehead, clearing away the last flickers of thought like a slow mist. The mind begins to drift, no longer seeking answers or patterns in the silence. It is a soft, blurring sensation, where the edges of the room and the edges of the self begin to merge into the dark. Every cell is now synchronized with the slow, deep rhythm of rest. The weight of the blankets is a warm and protective shield against the outside world. This is the moment where the journey ends and the quiet begins. You're safe, you're still, and you're ready for the deep, dreamless pull of the night. And now, 101 wonders are resting with you. Sleep now. Good night.